Hello lovely student, welcome to Silence Classes e-learning platform. Let's start a new chapter, Understanding Elementary Shape of Class 6. Okay, this is the introduction part of the video. Over here, I will explain each and every concept, okay, regarding this particular chapter. You will understand each and everything, okay, so you can do the question by yourself, okay. I will explain you each and everything, each and every concept in the easiest manner, okay, it is possible. So, the topic is line segment. What the exactly line segment is? Line segment, if we draw any line and if we know the starting and the end point of that particular line is known as line segment. Okay, line segment means we know the starting and the end point. Okay, so that is known as line segment. Now, if we are having 2 or 3 lines, okay, by just observing we can find it out which line is greater and which line is smaller. Okay, I hope बेटा आप लोग को समझ में आ रहा होगा. Means you can find it out which line is greater and which line is smaller. Okay, if I will ask you this one is line 1 and this one is line 2, okay, if I will ask you which line is smaller and which line is greater, so you can easily by just looking these two figures you can find it out. Line 1 is bigger and line 2 is smaller. Line 2 is smaller. Okay, so this is known as observation method. This is known as observation method. By just looking the figure we can identify, okay, which one is greater and which one is smaller by using the tracing paper. Okay, I hope you guys know what the tracing paper is. In the tracing paper we can mark any line, okay, any line, even or first one or the second one, we can take any line, okay, and we can put that particular line on the other line. Okay, after that we can trace it like this. Okay, so we can just find it out that which line is greater and which line is smaller, which line is greater and which line is smaller, okay, by using the tracing paper. Now if I will draw a lines like this, okay, there is a slight difference in the line but you cannot identify by just looking it. Okay, so for this types of questions we will use the divider or the ruler. Okay, by using the ruler or the divider we will get the exact length of that particular line. Okay, by using the exact length of that particular line we can easily identify which one is smaller and which one is greater. Okay, so by putting if we will use the ruler, I hope you guys know how to use the ruler. If we are using the ruler, we will put one end means 0 at the one end of the line and then we will check it out where the line is ending. Okay, then we will calculate it and we can find it out, okay, the length of that particular line. Okay, and by using the divider in the geometry box, okay, divider is there in the compass box. Okay, in both the end there is a needle present. Okay, so you can place the one end of the divider over here means one needle and the second needle over here at the end of that particular line. Okay, then we can put these two lines over here in the scale. I can mark it out like this one is 0. Okay, this one is 0. So like this we can mark place the one end at the 0, and for an example if the second end is coming at 3 centimeter over here. Okay, so we can easily check it out that the line is of 3 centimeter. Okay, or it can be 6 centimeter, it can be 7 centimeter. Okay, so by using that particular thing means divider, we can easily find it out the exact length of that particular line. Okay, now we will talk about angles. Okay, in this particular chapter we will talk about some angles. Okay, 6 or 7 types of angles over here. Okay, there are several angles but we will not talk over here in this particular chapter. So first of all we will learn about 3 angles. Okay, that is acute angle. Okay, acute angles are angles which are less than 90 degree, which are less than 90 degree. Okay, 90 degree angles are like this. Sorry. Okay, if we draw a 90 degree angle, it's a straight angle, okay, like this. Okay, and this line is known as perpendicular. This line is known as perpendicular. Okay, and between these 0, this one is 0 and this one is 90. Okay, between these angles, okay, 90, between 90 and 0, whichever angles you are having, okay, the name of that particular angle is acute angle. Okay, the name of that particular angle is acute angle. Okay, it can be 89 degree, it can be 89.5 degree, it can be 86, it can be 1 degree, 2 degree, anything. Okay, these angles are known as acute angle. Okay, now if we will talk about obtuse angle, obtuse angles are greater than 90 degree but smaller than 180 degree, smaller than 180 degree. Okay, starting from 0 and this one is 180. Okay, this is a straight line of 180. So between these two angles, between 90 and 180 degree, whichever angle we will talk about, okay, it is known as obtuse angle. It is known as obtuse angle. Okay, and now we will talk about the reflex angle. Reflex angle means greater than 180 degree and is smaller than 360 degree. Okay, means all these angle, between these angle, okay, all the angle is known as reflex angle. All the angles is known as reflex angle. Okay, so 90 angles, it's not always come like this. Okay, it will not always be given like this. Okay, it can be like this. Okay, it can be like this, it can be like this. Okay, just you have to find it out. The base, okay, the base should be straight and the perpendicular should be straight. Okay, then only we can say that these are means 90 degree angle. Okay, and acute angle can come like this. So we will draw an imaginary line like this. Okay, the straight line, we will mark one base. The baseline is this. Then by this particular baseline we will draw a straight line. Okay, means a perpendicular, straight perpendicular. Okay, if the angle is smaller than this particular line, then it is known as acute angle. If it is greater than this imaginary line, then we can say it is obtuse angle. Okay, it is obtuse angle. Okay, I hope you guys understood what the acute angle is, what the obtuse angle is, and what the reflex angle is. Okay, means greater than 0 and less than 90 degree is all the angle between these two points are known as acute angle. Okay, obtuse angle is greater than 90 degree and smaller than 180 degree. Okay, and reflex angle is greater than 180 degree and smaller than 360 degree. Okay, now let's talk about three more angles, that is known as right angle, straight angle, and complete angle. Okay, means right angle, 90 degree angle. 90 degree angle is known as right angle triangle. Okay, means like this. Okay, 90 degree angle is like this. Okay, so it is known as right angle triangle. It is known as right angle triangle. Okay, if I will talk about straight angle triangle, means if I will draw a line like this, okay, it is a 180 degree line. It is a 180 degree line, and this line is known as straight angle. This line is known as straight angle. Okay, and if we will talk about a complete zero, this is known as complete angle. It is known as complete angle. Okay, and it is of 360 degree. 360 degree. Okay, if there is it is written that we are having a 360 degree angle, name that particular angle. So we will straight away write it down. It is a complete angle because it is of 360 degree. Okay, I hope you guys understood. Now by using the clock, we will talk about the revolution and we will learn more about the 90 degree angles, straight angle, and the complete angles. Okay, the clock is always moved like this, in this direction. Okay, the clockwise direction like this. Okay, so if the clock is moving like this, so this is forming a right angle triangle. This is forming a right angle triangle. Okay, right angle triangle means it is of 90 degree. 90 degree. Okay, if we will talk about the revolution means the complete 360 degree. Complete 360 degree. If we take a clock, it is of complete 360 degree. Okay, we will start from 0 and come exactly round and round, and then exactly comes to 12 again. Okay, so we will talk about 360 in this. That's why if I want to know, if I want to know how much revolution the clock has completed over here, okay, if it is moved from 12 to 3, so we can say it is making a 90 degree angle. So 90 upon 360, So 0, we can cut 0, 9 ones are 9 and 9 fours are 36. So we can say that 1 upon 4 revolution, okay, we have completed. We have completed, okay. And if we will talk about a straight angle, okay, if we will talk about a straight angle, that means it is a complete 180-degree line, means a straight line like this, okay. So we have completed 180-degree. So how many revolution we have completed over here? So we can check it out by putting 180, okay, upon 360 by this. 18 ones are 18, 18 2 are 36. We can say 1 upon 2 means half, or we can say 1 upon 2 revolution we have completed. We have completed 1 upon 2 revolution, okay. Now if I will talk about the complete angle, okay, so complete angle is of 360 degree, okay. So that 360 upon 360 degree, it will come 1, means 1 complete revolution we have completed over there, means 360 upon 360, okay, means it will come 1 around 360, ones are 360, okay. So 1 will come, so we can say that complete 1 revolution means we have completed 1 revolution, okay. Okay, if we have completed 360 degree, okay. So by this we can check it out how many revolution we have completed by using the straight angle, by using the right angle triangle and 360 degree angle, okay. I hope you guys understood, because in this particular chapter you have to use this clock, and the second method is the direction, okay, to find out the revolution, okay, of that particular thing, okay. Now if we will talk about the angles, knowing angles with the help of direction, so we are having, you guys know, east, west, north and south, okay. And from north to east, okay, east to south, south to west and west to north, okay, we are having 90-degree angles. We are having 90-degree angles, okay. So if we will move from north to east means we have completed 90-degree. If I will talk about how many revolution we have completed, again you have to write it down, 90 upon 360. By this you can check it out easily, 1 upon 4 of the revolution we have completed by this, okay. If I will talk about from north we have moved to south, how many revolution we have completed? So we can say that it is a straight line, this means 180-degree line, so we can say 180 upon 360 means 1 upon 2, yani half, okay, means 1 upon 2 revolution means half revolution we have completed. Again if we will move from north to north, okay, reach north, then we can say we have completed 360 degree. 360 degree means we have completed one revolution, okay. So by using this, by the help of direction, by the help of time, we can find it out. By using the right angle triangle, straight angle and the complete angle, we can easily find it out how much revolution we have completed, okay. Please do like and subscribe my channel, okay, if you guys like my videos, okay. Now let's move to the next question, topic, okay, about some perpendicular line. Perpendicular, okay, means the straight line segment falling, okay, or we can say a straight line falling to a line like this. A straight line is falling, okay, on a line is known as perpendicular, okay. So now this is known as perpendicular, this is known as perpendicular, this one, and this is known as perpendicular line, okay. So perpendicular is a straight line falling, okay, falling on a line, okay. So this is known as perpendicular, okay, and this perpendicular is falling in a line, this is complete known as perpendicular line. It is known as perpendicular line, okay. Now what is perpendicular bisector? Perpendicular bisector is really an interesting concept, okay. Means bisector means dividing that line into two equal half, means if we are having a line like this of 4 centimeter, okay, if we will draw a line of 4 centimeter, if I will draw a perpendicular bisector on this particular line like this, okay, if we draw a perpendicular on this line, okay, and if this perpendicular is dividing this line into two equal half means from here if I will write it out, A, O and B means AO is equals to 2 centimeter and OB should be equals to 2 centimeter. Okay, means wherever this perpendicular is dividing the line, okay, both left and the right line should be equal, okay, then only we can say this is a perpendicular bisector. Okay, perpendicular bisector always divide a line into two equal half. Okay, so I hope you guys understood. Okay, the concept is very easy, very easy. A straight line is known as perpendicular, a straight line is known as perpendicular. Okay, falling, if it is falling, this perpendicular is falling in any line, on any line, this line is known as perpendicular line. Okay, and if this perpendicular is dividing this line into two equal half, then we can say this is a perpendicular bisector. Okay, now let's move to the next concept, that is classification of triangle on the basis of side. Okay, if we will talk about a triangle, okay, on the basis of sides, we can say it is a scalene triangle, isosceles triangle or equilateral triangle. If we draw a triangle, okay, like this, the concept is very easy. Okay, please try to grab it. Okay, if scalene triangle means A, B and C, we are having three line segment in this, AB, BC and CA, AB, BC and CA. Okay, if all the three lines, this one and this one, all the three lines, okay, length is different. Okay, means if it is of 3 centimeter, it is of 4 centimeter, it is of 5 centimeter, all the three lines are different, then we can say it is a scalene triangle. Okay, means all the lines are different. Okay, the length of all the lines, okay, are different. If I will talk about isosceles triangle means any two side of this particular triangle should be equal. Okay, it can be this one, it can be this one, like we can write it down 4 centimeter over here and we can write it down 3 centimeter over here. Okay, so any two side should be equal. Okay, then only we can say it is an isosceles triangle. Okay, triangle means three sides are there, okay, in isosceles two sides should be equal. Okay, two sides should be of same length. Okay, in scalene, okay, all the sides are different, all the three sides are different. In equilateral triangle, equilateral means equal, all the three sides should be equal, means all the three sides should be of 3 centimeter, 4 centimeter, 5 centimeter. Okay, all the three sides should be equal. Okay, so by this I hope you guys understood what the scalene triangle is, isosceles and equilateral triangle. Now if we will talk about on the basis of angles, okay, so acute angle triangle, I've already told you acute angle. What the acute angle is? Acute angle is greater than 0 and less than 90 degree. Okay, means any triangle like this, is known as acute angle triangle, because if I will put the protector over here, okay, the line, if I mark an imaginary line like this, okay, so we can see it is smaller than 90 degree. Over here if I will put it out, we can say it is also of 90 degree, is smaller than 90 degree, so we can say it is an acute angle triangle. Okay, means these angles should be smaller than 90 degree. Okay, if I will talk about a right angle triangle, you by the name is already clear. Right angle triangle means the angle should be of 90 degree. Okay, means like this. Okay, means one angle is of 90 degree. Okay, if there is a 90 degree angle present, so we can say it is a right angle triangle. Okay, in the obtuse angle triangle, angle should be greater than 90 degree. Greater means the angle, this is a 90 degree, so it can be like this, Okay, so all these angles which are greater than 90 degree, okay, greater than 90 degree, you can just observe it, okay, and you can tell whether it is a 90-degree triangle, or it is a acute angle, or it is a right angle triangle, or it is a obtuse angle triangle, okay. But you just have to clear the concept. Acute angle is of less than 90 degree, right angle is exactly of 90 degree, and obtuse angle is always greater than 90 degree and smaller than 180 degree. By this you can easily find it out which triangle is it, okay. Now let's move to the quadrilateral. What the quadrilateral is? Quadrilateral, any closed figure, okay. If there is any closed figure having four sides, okay, a closed figure having four sides should be there, okay, and it should be made up of line segment, okay, line segment, okay. If I will make a figure like this, okay, so it is a closed figure, but it is not a quadrilateral, okay, because a closed figure having four sides, okay, made up of line segment, it can be like this. It is a closed figure having four sides, okay. It can be of like this, okay. It can be like this, okay. So all the closed figures having four sides is known as quadrilateral, okay. For an example, if we will talk about rectangle like this, okay, square, parallelogram, rhombus, trapezium, okay, all these are closed figure having four sides, okay. So it is known as quadrilateral, okay. Please note down the definition. A closed figure having four sides made up of line segment, okay, made up of line segment. You can check it out, all the line segments are there, okay, because we know the starting and the end point of this particular lines, okay, of these particular lines, okay. Now what is a polygon? Polygon means any closed figure, okay, made up of line segment. It should be made up of line segment, okay. It doesn't matter it is of whether it is having three sides, whether it is having four sides, whether it is having five side, 8 side, 10 side, okay, it doesn't matter, okay. It should be made up of line segment and it should be of closed figure, okay. Means quadrilateral is also a polynomial, okay. Quadrilateral is a polynomial. All quadrilaterals are polynomial, but all polynomials are not quadrilaterals, okay. All polynomials are not quadrilaterals because polynomials are of 6 sides, 8 sides, 5 sides, but quadrilateral is specific. Quadrilaterals are having only 4 sides, okay. So all the quadrilaterals are polynomials, but all the polynomials are not quadrilaterals, okay. So triangles having 3 sides, okay, is a polynomial. It is a closed figure, okay, made up of line segment. Quadrilaterals, all the quadrilaterals I have already explained you. Pentagon having 5 sides, okay, like this, 3, 4 and 5, like this. Hexagon having 6 sides, like this, 1, 2, 3, 4, 5, 6, okay. Octagon is like this only, okay, having 8 sides, okay. So I hope you guys understood what the polynomial and the quadrilateral is, okay. So the concept is very easy, beta. All the quadrilaterals are polynomials, but all the polynomials are not quadrilaterals. Any closed figure made up of line segment, okay, like this, lines, okay, not like this, straight lines should be there, okay, straight lines should be there, made up of line segment is known as polynomial, okay. Now this is the last concept of this particular chapter, okay. Over here, after this we will wind up this introduction part of this particular chapter, okay, and then move to the questions, okay. Now we will know what the faces is, edges and vertices, okay. If we will draw a 2D figure like this, okay, in 2D figure you can check it out. This is a face, okay. If I will take this box, okay, this is a 3D box, okay. In this 2D figure we are having only one face, okay, but if we will see this 3D figure, we are having 1, 2, 3, 4, 5 and 6 faces, okay. In 2D figure we are having only one face, okay, but in 3D figure we are having altogether 6 faces, okay. Now edges means the joining, the lines which are joining 2 points, like this. We are having 4 points like this. Okay, if we will draw a line like this line is known as edge, this line is known as edges. This one, this one, this one, and this one. Okay, there are 4 edges in this particular 2D figure, okay, we are having 4 edges in this particular 2D figure. But if I will check it out in this 3D figure beta, so you can check it out 1, 2, over here 3, 4, okay, 5, 6, 7, 8, okay, 8 edges are there. 8 edges are there in this particular 3D figure. Okay, so this is known as edges. Okay, joining 2 points. Okay, this line is joining these 2 points, okay, so it is known as one edge. Second one is this, third one is this, fourth one is this, okay, fifth, sixth, seventh, and eighth. Okay, I hope you guys understood. Now what is vertices? Vertices means the point. Okay, the point edges, okay, these points like over here, over here, over here, over here, okay, the points edges are joining, these points are known as vertices. Okay, what are vertices? Vertices are the points edges are joining. Okay, edges are joining these vertices, okay, the points. Okay, if I will check it out in the 2D figure, how many points are there? 1, 2, 3, and 4. 1, 2, 3, and 4 points are there. But if I will talk about over here in 3D figure, you can check it out. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 vertices are there. How many vertices are there, beta? 8 vertices are there. Okay, I hope you guys understood what exactly the face, the edges, and the vertices are. Okay, if you guys like the introduction part, please do like and subscribe and share with your friends. We're going to start exercise 5.1, question number 1. Let's check it out what the question is saying. What is the disadvantage in comparing line segment by mere observation? Mere observation means, beta, that we have to look the lines which are given to us and tell about them. Okay, so what is exactly the disadvantages by just looking out these lines and telling about them? Okay, if we just look the lines, okay, we can only identify whether the lines, which line is greater or which line is smaller. Like say, is this line number 1 and this is line number 2. So by just looking these two lines, we can only say that line 1 is greater than line 2 and line 2 is smaller than line 1. Apart from this, we cannot clarify anything else. Okay, how much it is smaller and how much line 1 is bigger, we cannot tell that, or we cannot tell the exact length of line 1 and line 2. Okay, so this is the main disadvantages of just by looking, okay, and telling about the line. Okay, I hope you guys understood. Okay, number 2 we are doing. Let's check it out what the question is saying. Why is it better to use a divider than a ruler while measuring the length of a line segment? Okay, exactly, we guys always use a ruler to find out the length of any line. Okay, because we used to place the one point at 0 and we can check it out the another point like this. Okay, maybe if this point is 0, then we will put like this and then we will calculate like this. Okay, 0, 1, 2, 3, 4, okay, and 4.5 like this. But why is it better to use a divider? Okay, they are asking. So if we place, whenever we are using the divider, as the divider is pointed needles, the pointed needles are present on the divider, so for the minute difference of these, means 4.5, 4.6, this 6.7 point, okay, because we are checking the lines, okay, maybe the thickness, okay, of that particular line can cover that to one point, okay. So while using the divider, we will exactly place the point, okay, on the points like this. Like this one is 0, we will place one point over here like this, and the second like this. Then we can easily count it out, okay, means 1 2 3 5, 3.5, 6 and 7 like this, okay. So that's why, maybe that's why they are saying the divider is much better than a ruler, okay. But basically we always use a ruler to find out the length of that any line, so we find it very easy, okay. But if you guys check it out by the divider, you will find much easier, because you will get the exact points, okay, whenever you will place on the ruler, okay. But please try not to means dislocate, okay, the divider, okay. Once you will open that divider, okay, so you have to place it like that only, okay. Don't move that divider, okay, don't move that divider, otherwise your length will be differ, okay. Next question we will do is, let's continue with the question number 3. Let's see what the question is saying. Draw any line segment, say AB, means we have to draw any line segment, name AB, take any point C lying in between A and B, okay, means we have to mark any point, okay, anywhere in between A and B, okay. Measure the length of AB and BC and AC, okay, means we have to measure the length AB and BC, okay. Is AB is equals to AC plus CB, okay. They are asking, is AB is equal or not. So let's draw, first of all let's draw a line segment. Let's say I'm marking over here 0, okay. So 0, 1 centimeter, 2 centimeter, 3, 4, 5, 6 like this, okay. 6 centimeter line I have drawn, okay. So take any point C lies in between A and B, okay. Between A and B means in 2 centimeter, 3 centimeter, 4 centimeter, wherever I want I can place the point, okay. So I am marking over here in 2 centimeter, over here in 2 centimeter like this, okay. I am marking that point, okay. So I have marked that point over here in 2 centimeter, okay. So this point is A, this one, and this one is B, okay. And we have marked C over here, okay. So now it is asking AB, if I will mark like this, AB, okay, is of 6 centimeter, is equals to AC plus CB. Yes, of course it is equal, beta. Why? Because AC is equals to, if AB, I have taken AB is equals to 6 centimeter, okay, and AC is equals to 2 centimeter. It means CB is obviously 4 centimeter. CB is equals to 4 centimeter. So AC plus CB is always equals to AB, okay. Of course, beta, AB is always equals to AC plus CB, okay, because it is a midpoint. It is a point present in between A and B, okay, between A and B. And now note is given, if ABC are any 3 point on a line segment, that AC we are talking about this line, AC plus CB is equals to AB, okay, it is always equals to AB. Then we can be sure that C lies in between A and B. Then we can say sure that C lies between A and B, okay. Yes, it always lies in between A and B, okay, but it can be anywhere in A and B, okay. It can be anywhere between A and B, okay. But we can place C at 2 centimeter, at 3 centimeter, at 4 centimeter, at 5 centimeter, anywhere we can place 5.5, 5.6, okay, but it should be placed between A and B only. Okay, yes, we can say that it is always, C point is always between A and B. Okay, I hope you guys understood better. Question number 4 of this exercise, let's check it out what the question is saying. If A, B, C are the 3 points on a line, okay, means we have to draw a line where A, B and C points are there. Let's say we will draw a line like this. We will draw a line like this. Okay, we will mark a point A over here, B over here, and C is over here. Okay, let's mark B over here. Just a second, guys. I will draw a line like this: A, B, and C. Okay, like this. AB is equals to 5 centimeter, means AB is given to us, means this is 5 centimeter. BC, this one from here to here, okay, this is 3 centimeter. Okay, and AC means A and AB plus BC is always equals to AC, and AC is always equals to the sum of AB plus BC. 5 plus 3 is 8. That's why AC is equals to 8 centimeter. Okay, which one of them lies between the other two? Means the point means A, B and C. Which one is lie between the other two? Okay, it is, without using this line you can check it out by here only, that B is the midpoint. B is between AB and BC. Okay, B is always lie between the other two. Once you have drawn the line, you can easily check it out. A, B, B, C. B is in between A and C. Okay, but without using this line, by just looking this, you can say that B is the midpoint. Why? Because B is not the midpoint, B is between. Okay, why it is so? Because AB is equals to 5 centimeter and BC means from B, the other line is starting from B and moving towards C. Okay, so once we will draw AB like this, B, then from B we have to start to C, BC. Okay, so B is over here also, AB, in AB B is also there, and in BC B is there. Okay, so we can say B is between the other two. Okay, I hope you guys understood better. Okay, next question is 5.1. question number 5 we are doing. Let's check it out what the question is saying. Verify whether D is the midpoint of AG. Means we have taken AG and we have to find it out D is the midpoint or not. Okay, so first of all you have to check it out in this bit. Like, we are starting from 1. Okay, we are starting from 1. If you take a ruler, okay, and 0 is not there, okay, means your scale is broken from the front. Okay, from the starting point 0, so you can mark 1 as the starting point. Okay, so 1, from 1 to 2 is 1 centimeter. Okay, so over here we have taken 1. Okay, A, we have marked A at 1. So from 1 to 2 is 1 centimeter. 2 to 3 means from B to C is 1 centimeter. We are having 1 centimeter gap. Okay, like in your scale. Okay, so 1 centimeter. AB is equals to 1 centimeter. BC is equals to 1 centimeter, and CD is equals to 1 centimeter. Okay, now DE is also 1 centimeter beta. DE is 1 centimeter. EF is 1 centimeter, and F and G is equals to 1 centimeter. Okay, and D is the midpoint. We have to prove. So AB plus BC plus CD, if I will add all the three, it will come 3 centimeter. If I will add DE, means over here DE, EF and FG, if I will add, it will come 3 centimeter. It means 3 centimeter is from A to D and 3 centimeter from D to G. So we can state that D is the midpoint because 3 centimeter is equals to 3 centimeter, and midpoint means divide any line. If there is a midpoint, it means dividing, midpoint is dividing any line into two equal parts, okay. And though we are placing A over here in first, okay, that's why we can say we have to calculate from 1 only, okay. That's why we can say D is the midpoint. Yes, verify, we have verified that 3 centimeter is equals to 3 centimeter, means D is the midpoint of A and G, okay. I hope you guys understood. Okay, exercise 5.1 question number 6 we are doing. Okay, let's check it out what the question is saying. If B is the midpoint of AC, means we have to draw a line AC. Let's say draw AC line like this. Okay, we have drawn AC is equals to 4 centimeter. Okay, this one AC is 4 centimeter. B is the midpoint. Midpoint means like over here. Midpoint means AB is also 2 centimeter. If it is midpoint, then AB is equals to 2 centimeter and BC is equals to 2 centimeter. Okay, then only it is a midpoint. Okay, so AB is equals to 2 centimeter and BC is 2 centimeter. Okay, C is the midpoint of BD, means we have to draw BD. Okay, means from B we have to move to D from C. So C is 2 centimeter. C is the midpoint. Midpoint means it is in the center. So if BC is 2 centimeter, then CD, then if we will draw a line like this, CD will also of 2 centimeter, because C is the midpoint. Okay, midpoint of BC, then 2 centimeter plus 2 centimeter, 4 centimeter, and 2 is the midpoint. So it is the midpoint of BD. Where ABCD lies in a straight line? Yes, it is lying in a straight line. ABCD is a straight line. Say why AB is equals to CD. Why AB is equals to CD? Because both the lines are equal. Because AB is also 2 centimeter and CD is also 2 centimeter. Both AB and CD are of 2 centimeter. That's why we can state that, or we can say that AB is equals to CD. Okay, I hope you guys understood, because all the things is given over here, that midpoint, we have to understand the midpoint concept. Okay, midpoint means at the center, okay. So midpoint of A and C, that is B, and I have drawn AC is equals to 4 centimeter, midpoint is 2 centimeter. Okay, if BC is 2 centimeter, okay, then CD is also 2 centimeter, because C is the midpoint of BD. Okay, so all the lines AB, BC and CD are of 2 centimeter. That's why it is equal. And there is one more concept by which we can say that AB is equals to CD. Okay, how? Let's say it is saying that there is a line AC and B is the midpoint of AC. Means if we draw a line like this, A and C, and B is the midpoint of AC, so we can say AB is equals to BC. Okay, by this we can say that. Why? Because AB is equals to BC, because B is the midpoint. Okay, now it is saying C is the midpoint of BD, means we have to draw a line BD like this, and C is the midpoint. C is the midpoint of B and D. So we can say midpoint means at the center or in between. So BC is equals to CD. By here you can check it out. AB is equals to BC and BC is equals to CD. Okay, means all these lines are equal. AB is equals to BC and BC is equals to CD. Okay, by this also you can say AB is equals to CD, because all the lines are equal. Okay, this is the another way, okay, by which you can find it out. Okay, 5.1 question number 7 we are doing. Let's check it out what the question is saying. Draw 5 triangles and measure their sides. Means we have to draw 5 triangles in this. Check in each case if the sum of the length of any 2 sides, means we have to add 2 sides of that particular triangle, and we have to tell this 2 side is always less than the third side or not. Okay, is the sum of 2 side is less than the third side or not. Okay, first of all I want to tell you guys that it is a universal truth, and it is proved that the sum of 2 sides of a triangle is always greater than the third one. Okay, so whenever this type of questions is there, okay, you guys know that the sum of 2 sides is always greater than the third one. You guys can draw as many triangle as you want and you can check it out. Okay, let's take a 2 centimeter line like this. Let's draw a 2 centimeter line, 1 and 2 centimeter line like this. I've drawn 2 centimeter line over here. You can take 4 centimeter, 5 centimeter, okay, whatever you want to take. Like this, I am taking around 3 centimeter line, 1 centimeter, 2 centimeter and 3 centimeter line is there. Okay, 3 centimeter line is there. Now if I will draw a line like this, okay, I will check it out what is the coming. 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 4.3. If I will draw like this, okay, the line is 4.3. okay, you guys can check it out. Okay, maybe your line will be differ because you will not make exactly like this. Okay, so but if you will add any two angles, let's say this one is A, B and C. Okay, let's add AB plus BC. Let's check it out. AB is 2 centimeter plus 3 centimeter is 5 centimeter. It is greater than the third one. Okay, let's check it out. AB plus AC. Okay, AB is 2 centimeter plus AC is 4.3 centimeter. Okay, it is coming 6.3 centimeter. It is greater than BC. Okay, the third one. Now let's check it out. AC plus BC. Okay, AC plus BC means 4.3 plus 3. It's 7.3 centimeter. 7.3 centimeter. It is greater than AB. Okay, so I'm drawing one triangle over here. Okay, you guys can draw as many triangle as you guys want and you can check it out. Okay, always the sum of 2 side is always greater than the third one. Okay, I hope you guys understood. Check it out the playlist. Let's continue with exercise 5.2 question number 1. What the question is saying: what fraction of a clockwise revolution does the hour hand of a clock turns through when it goes from 3 to 9, 4 to 7, or these questions are given. Okay, so first of all we have to find out the fraction, okay, of the clockwise revolution. So first of all we have to find out the degree, what sort of degree these hour hand is forming. Okay, so to find out the degree what the hour hand is forming, I will tell you the easiest way to do that. Okay, just remember 1 hour, or you can say 1 unit, is equals to 30 degree. 1 hour is equals to 30 degree. Means if the hour hand is moving from 12 to 1, it is moving 1 hour. 1 hour is equals to 30 degree. If it is moving from 12 to 2, 12 to 2 means it has completed 2 hours, or you can say it has moved 2 unit, 1 unit from 12 to 1 unit, and 1 to 2 2 unit. So 2 hours, or you can say 2 unit multiplied by 30 is equals to 60 degree. Okay, so means 1 hour, or you can say 1 unit, is equals to 30 degree. Okay, if you have to calculate 10 hours, or you can say 10 unit, okay, you will multiply it by 30. 9 you will multiply it by 30. If it is moving 5 unit, you will multiply it by 30. No need to learn or mug up the things like the straight line is of 180 degree, reflex angle is of 270 degree, 90 degree angle, or anything like that. Okay, please don't do it like this. Okay, learn that 1 hour is equals to 30 degree. Okay, just remember this formula. Okay, you can find out each and every, means you will find out each and every degree, okay, whatsoever the clock is moving. Okay, so now let's check it out. From 3 to 9, means the clock is at 3, the hour hand is at 3, move the clockwise like this and came to 9. Okay, now let's check it out how many hours it has completed or unit it has moved. 3 to 4 1 unit, 4 to 5 2 unit, 5 to 6 3 unit, 6 to 7 4 unit, 4 to 8 5 unit, and 8 to 9 6 unit. You can say 6 unit or 6 hours, both are equal. So 6 multiplied by 1 hour is equals to, or 1 unit is equals to 30 degree. So 30 is equals to 180 degree. Okay, now one thing, whenever we have to make a fraction, you know that one complete revolution is of 360 degree. If the hour hand is moving from 12 and came back to 12, okay, it moves 360 degree. How it is possible? You can multiply 12 unit or 12 hours is multiplied by 30 is equals to 360 degree. You guys can check. It means it is clear that one complete revolution is of 360 degree. So if we have to find out the fraction, okay, or the clockwise revolution, so we have to divide it by 360. So 180 divided by 360, 18 ones are 18, 18 2s are 36, means 1 upon 2 revolution. Okay, or you can say fraction is 1 upon 2, 1 upon 2. Okay, so this is the answer. Now let's move to the second question from 4 to 7. Okay, from 4 to 7. Now check it out the hours, or you can say unit. 4 to 5 1 unit, 5 to 6 2 unit, and 6 to 7 3 unit. So total 3 unit. 3 multiplied by 30 degree multiplied by 30 is equals to 90 degree. Okay, don't learn like it is making 90 degree angle. Okay, so it is of 90 degree. Okay, don't do it like that. Okay, because whenever the clocks are like this, 4 to 7 5 to 8 like this, you will not able to find out whether it is making a 90 degree angle or not. Okay, if the hour hand is at 12 and the moving towards 3, then you can identify that yes, it is making a 90 degree angle. Okay, but each and every time you will not able to find out that it is making a 90 degree angle or not. So please, okay, so learn this R concept what I am teaching you right now. So 90 degree upon 360, 0 0 9 1s are 9 and 9 4s are 36, means 1 upon 4, 1 upon 4. Okay, and this is the answer. Okay, this is the fraction 1 upon 4. Let's move to the third one from 7 to 10. From 7 to 10. See, is it easy to find out whether it is forming a 90 degree angle or not? No, it is not easy. So we can check it out. 7 to 8 1, 8 to 9 2, 9 to 10 3, and 3 multiplied by 30 is equals to 90 degree. 90 multiplied by 3, sorry, divided by 360, we will get 1 upon 4. Okay, 9 1 9 and 9 4 36, 1 upon 4 revolution, or you can say 1 upon 4. This is the fraction. From 12 to 9, 12 to 9, it is moving from 12 to 9. Okay, we are moving clockwise direction because in question it is given clockwise revolution we are doing. Okay, so it is moving like this. So let's check it out. 12 to 1 1, okay, 2 3 4 5 6 7 8 9. Okay, 9 multiplied by 30 is equals to 3 9s are 27, 270 degree. 270 upon 360. Okay, and 3 9s are 27, 3 12s are 36, 3 3s are 9, and 3 4s are 12. So we will get 3 upon 4. 3 upon 4, this is the fraction and this is the answer. 3 upon 4 is the fraction. Okay, what we have to find out. From 1 to 10, from 1 to 10, like this in a clockwise direction. So let's check it out. 1 to 2 1, 2 to 3 2, 3 4 5 6 7 8 and 9. 9 unit, or you can say 9 hours. 9 multiplied by, again 9 multiplied by 30. Each angle, or you can say each hour is of 30 degree. Please do remember this. 3 9 to 27, again 270, 270 upon 360, like we will get around 3 9 to 27, 3 12, 3 3 is 9, 3 4 is 12, means 3 upon 4. 3 upon 4 is the answer. Okay, let's do the last one of this question, question number 1. Okay, from 6 to 3. From 6 means we are standing at 6 and moving towards clockwise direction to 3. Okay, so 6 to 3, let's check it out. 6 to 7, 1 2 3 4 5 6 7 8 and 9. Again 9. 9 multiplied by 30 is equals to 270 degree. 270 upon 360 is, if we will cut it, we will get 3 upon 4 revolution, and this is the answer. Okay, I hope you guys understood. This is the easiest way to do this question. Okay, 5.2 we are doing. All the previous exercise we have already completed. You guys go and check it out. Let's see the question number 2, what the question is saying. Where will be the hand of clock stop if it start at 12 and make 1 upon 2, or you can say half of the revolution clockwise. Okay, means we have to find where the R hand will stop now. Okay, so in this particular question, what we have to do, the R hand is at 12 like this, it is like this. Okay, and it is moving a half of the revolution. A half of a revolution means 1 upon 2. Okay, so 1 upon 2 of the revolution. So if we have to take half of the revolution, we have to multiply it by 360 degree. Okay, now we will multiply it by 360 degree, so we will get how many degree it has moved. Okay, so find out the degree, how many degree the angle or the R hand has moved. We will check it out. 2 ones are 2, 2 8 just 16, 0. Means if I will cut this 360 by 2, it will come 180 degree. Means 180 degree angle it has moved. Okay, and in the previous question I have already told you that 1 unit or 1 hour is of how many degree? 30 degree. So we will divide 180 by 30. Okay, 3 6 are 18, so we will get 6 as the answer. Means the R hand will start from 2 and make a half degree revolution, and hand will stop at 6 like this. Hand will stop over here at 6 like this. We can find it out, and this is the method to find out where the R hand will be. Okay, if it is moving a half degree revolution, or you can say half of a revolution. Okay, I hope you guys understood. Okay, so let's move to the next question. We will do it in the same way. Again, starting at 2, and it is moving in a clockwise direction. Okay, so half of the revolution, 1 upon 2, we will multiply it by 360. So again we will get 180 degree. Okay, so 180 degree, 180 divided by 30, and 3 1 3, 3 6 18. Okay, means 6 hours. 6 hours, or you can say 6 unit it will move. So we will move 6 unit from 2 to 3, 1 unit, 3 to 4, 4 to 5, 3, 5 to 6. Okay, again 1 2 3 4 5 6, it will move to 6 unit and it will stay at 8. Okay, means we are moving 6 hours. We are moving 6 hours from 2. Okay, or you can say 6 unit from 2. So 2 to 3, 1 unit, 2 unit, 3 4 5 and 6 unit. So we are moving towards 8 in a clockwise direction. So the R hand will stop at 8. Okay, and like this we will find out, okay, where the R hand will stop. Now let's start from 5. We are starting from 5 and we are again making a revolution in a clockwise direction. So 1 upon 4 multiplied by 360 degree, and 4 9s are 36, it will get 90 degree. Now 90 degree means we will divide it by 30, so it will get 3. I will get 3 hours, or you can say 3 unit we are moving. So we will move 3 unit from 5. 5 to 6 1 unit, 6 to 7 second unit, and 7 to 8 3 unit. Okay, or you can say 3 hours. So we will over here at 8, we will at 8. Okay, and this is the answer. We will stop at 8. This is the easiest way to do it, because 1 upon 4 divided by 90 degree, and making 90 degree from 5 is not as easy. Okay, making a 90 degree, so you can check it out. Each r is of 30 degree. Okay, or each unit of 30 degree, so we can say 30 plus 30 plus 30. Okay, so we will get 90. So like this we will directly divide it by 30, so we will get 3 hours. We will directly move to 3 hours. Okay, now let's move to the last question of this. We are making 3/4 of a revolution, and we are starting from 5. We are starting again from 5, and we are moving 3 upon 4. 3 upon 4 multiplied by 360, and 4 9s are 36, and let's check it out. 3 multiplied by 90, 3 9s are 27, means 270 degree we are moving. How many degree we are moving? 270 degree. So 270 degree divided by 30, and 3 9s are 27. So check it out, easily I got that we have to move 9 unit, or you can say 9 hours. Okay, or you can say 9 unit. So 9 unit, 5 to 6 1, 6 to 7 8, 6 to 7 2 unit, 7 to 8 3, then 4 unit 5 6 7 8 and 9. It means we are stopping at 2. We are stopping at 2. Okay, so we will directly get the answer that we are the R hand will stop at 2. Okay, so it is clearly asking where will the R of the clock stop. Okay, R hand of the clock stop, so we will get easily that we will stop at 2. Okay, I hope you guys understood. But, please don't try to learn 90 degree angles or 180 degree angles or 270 degree angles like this, because the way I am teaching you, you will find out exact value where you will stop the hand, because it can be come that our hand is at 7, our hand is at 8. Okay, move anti-clockwise or clockwise, so you will not face any problem. Okay, because you can calculate each unit. Okay, each unit you can move R, or you can say each unit. Okay, so 5.3 we are doing question number 3. Let's check it out what the question is saying. What direction will you face if you start facing? Means now we have to find out the direction. Okay, in this I have made a direction. Okay, that east, west, north and south. I have already also made northeast, southeast, southwest and northwest direction, but over here you will only come to know about east, west, north, south direction. Okay, so northeast, northwest, north, south, these all direction is not useful for you guys. Okay, so whenever we are talking about the direction northeast. Okay, northeast direction, wherever we are, so we will make a 90 degree angle. We will make a 90 degree angle. Let's say if we are over here in east, and we are moving towards south. We are moving towards south, so we are making 90 degree angles. 90 degree angles. Okay, so total we will make 490 degree angles. If we move from east to south, 90 degree, south to west, 90 degree, west to north, 90 degree, and north to towards east is 90 degree. Means we will make 490 degree angles. Okay, and you know 4 9 36, so means 360 degree. We will make a complete one revolution. Okay, so it is also one revolution is of 360 degree. Okay, but we will make 90 degree, 4 angles of 90 degree. Okay, so we will calculate likewise. Okay, so let's say question is saying we are standing in east and make half of the revolution. Half of the revolution means how much angle we have moved. Let's check it out. 1 upon 2 multiplied by 360 degree, like that only, which I have told you previously, because complete angle of 360 degree. Over here also it is of 360 degree, means 180 degree. Means we are moved 180 degree. Okay, means 290 degree angles we have moved. So now we are facing towards east. We are facing towards east, and we are moving clockwise. So let's move to 90 degree. Over here again 90 degree, 90 plus 90 180. It means we are facing west direction. Okay, so which direction we will face? We will face west direction. Okay, I hope you guys understood, because we are moving 180 degree, okay, and from east to south is 90 degree, south to west again 90 degree, 90 plus 90, 180 degree, it means we are facing west direction. Now let's move to the question number 2. We are again facing at east and make 1.5, means if we are standing at east, first of all we did one revolution is of 360 degree. So we have completed 360 degree, means we have started from east, we have completed 360 degree, again we are facing east, okay, again we are facing east direction. Now we have moved 1 upon 2 of the revolution, again we did 1 upon 2 of the revolution, so 1 upon 2. So now we will move half of the revolution, means 1 upon 2 multiplied by 360, again it will come 180 degree, okay. So 180 degree means 290 degree angles. So again we have started from east, we will move to south 90 degree, and again south to west, again we are facing west, so we will face west direction, okay. I hope you guys understood. 1 upon 2 means 1 means we have completed one revolution, okay, of 360 degree, okay. So if we start from east, we will, if we take a complete revolution, we will face east only. If we start from west, we will, if we take a complete revolution, we will face west only, okay. Now let's move to the next question. What the next question is saying, west, we are facing west right now, okay. Now we are make 3/4 of the revolution, but anti-clockwise. Let's check it out. 3/4 multiplied by 360, 4 9 are 36, and 3 multiplied by 90 is equals to 270 degree, means 90 plus 90, 180 plus 90, means we are taking 390 degree revolution, okay. But we are moving anti-clockwise. Anti-clockwise means we are moving in this direction, okay, like this is known as anti-clock, okay, anti-clock direction, okay. So we are facing west to south, because we are moving anti-clockwise, so we will move like this, west to south 90, south to east 90 plus 90, 180, again 90 degree we have to move, because we have to move 270 degree, so we will face north, okay. We will come over here and we will face the north direction, okay. Just please read out the question whether we are moving anti-clockwise or clockwise, okay. If we move clockwise, we will move like this, okay, but we are moving anti-clockwise, that's why we are moving in this direction, okay. Now let's move to the last question. We are facing south and we make one full revolution. One full revolution means 360 degree, okay. So in one full revolution, there is one thing, if we move clockwise like this, one complete revolution, we will face south only. If we move anti-clockwise also, then also we will face south only, okay. So whenever we are taking a complete full revolution, it doesn't matter whether we are moving anti-clockwise or clockwise, okay, we will face the same direction, okay. So we will face the south direction, okay, if we are moving a one full complete revolution, okay. I hope you guys like my video. Please do like and subscribe. Question number 4 of exercise 5.2. Let's check it out what the question is saying. What part of a revolution have you turned through if you start facing? Mean if we are facing towards east, if it is given that we will move towards north or towards west or towards south, how many revolution we will take, means we have to find out the revolution. I have told you that if we are moving from north to east, it means we are moving 90 degree from north to east, 90 degree, every revolution is of 90 degree, 90, then again 90 plus 90 is 180 degree, Okay, means if we will move from east to south, we will move 90 degree. If we move from north to south, we will move 90 plus 90. Okay, means we will move 2 revolution means 90 plus 90. If we move from north to west, so 90 plus 90 plus 90, okay, means each revolution is of 90 degree. So how many revolution we have taken? We have taken 3 revolution, 1 2 3. Okay, and how many degree we have moved? You can say 90 plus 90 plus 90 means 270 degree. Okay, if we move from north to north, okay, then we will move 90 plus 90 plus 90 plus 90 is of 360 degree. Means how many degree we have moved? 360 degree. How many revolution we have taken? 1 2 3 and 4 revolution we have taken. Okay, how many revolution we have taken? 4 revolution we have taken. Okay, so now let's check it out. If we are facing east and turn clockwise to face north, okay, means I am standing over here. I am standing over here, and in the east facing the east, we will move clockwise like this, and we faced toward north. Means how many revolution we have taken? We are facing over here, means 1 and 2. How many revolution we have taken? Okay, we have taken 2 revolution. Okay, we can say how many revolution we have taken? 2 revolution. Okay, 1 and 2. So what part of the revolution you have turned through if you start facing? So how many revolution we have taken? 2. So we can write it down. 2 revolution we have taken, and if we have to write it down in the fraction, we can write it down 2 upon 4, because how many revolution are there? Complete 4 revolution are there. 2 upon 4 means we are facing over here. We have taken 1 and 2 revolution. To 2 upon 4 we have taken, means is equals to 1 upon 2. Okay, means 1 upon 2 revolution we have taken. 1 upon 2 revolution we have taken. Okay, if we have to tell how many degree we have moved, so we can say 90 plus 90, 90 plus 90, so 180 degree we have moved. I have explained you 3 things in this. Okay, only the revolution is asked in this particular question. Okay, so please don't get confused. I am explaining you, if in the question degree is also given, if the degree is asked from you that how many degree you have moved, so you can add like this, 90 plus 90, it will 180 degree. Okay, so now let's move to the next question, B part. But the question is saying, now where I am standing facing towards south, means I am standing over here. Okay, turn clockwise to face east. Now we have turned clockwise, means and toward east. Now I am over here. Okay, clockwise, so I will move like this, 1 revolution, 2 revolution and 3 revolution. Okay, I have taken altogether 3 revolution. Okay, to face the east direction. Okay, if we are talking about clockwise. Okay, so we can say how many revolution we have done? 3 revolution. Okay, or we can write it down in the fraction. How many revolution? 3 upon 4. Okay, and if we have to tell that how many degree we have to move, okay, so 90 plus 90 plus 90 is equals to 270 degree, means we have moved 270 degree altogether. Okay, and this is the second part. Okay, now let's move to the last part of this question, that is C. We are standing at west and turn clockwise to face east. Okay, now where I am standing? I am standing facing west, means I am standing over here, turning clockwise to face east. So 1 revolution and 2 revolution, means 2 revolution I have taken. Okay, in the fraction 2 upon 4 is equals to 2 ones are 2, 2 to the 4, means 1 upon 2 revolution we have taken. Okay, if we talk about degree, so 90 plus 90, 90 plus 90 is equals to 180 degree we have moved. Okay, I hope you guys understood. Okay, the question is very easy. I have told you in the easiest manner it is possible that in every revolution there is a 90 degree difference. Okay, means 90 degree difference means there it is of 1 revolution. How many revolution altogether are there? There are 4 revolution, from east to south, south to west, west to north and north to south. Okay, so like this we will move. Okay, east, south, west, north and then east. Okay, so we will do it like this. Have a Exercise 5.2 we are doing, okay, question number 5 of this particular exercise. All the previous questions are already there in the playlist. You guys can go and check it out. Introduction part is also there. I request you guys, please go and first of all watch the introduction part, because I have explained each and everything in the introduction part very briefly and in the easiest manner it is possible. Let's check it out what the question is saying. Find the numbers of right angles turned through by the hour hand of a clock when it goes from. Means we have to find out how many hour means right angles the hour hand is completing. Okay, question number 3 is saying the hour hand is at 3 and move towards 2 6. Okay, so from 3 to 6, so our hand is at 3 right now and move towards 6. Over here we can directly see that it is making a one right angle, okay, because it is very clear diagram, okay. But so I've explained you that to find out the exact value, how many angles or the degree the angle is moving, okay, we can multiply with the number of hours, okay. 1 hour is equals to 30 minutes, okay. 1 hour is of 30 minutes, means if clock is at 12 and move towards 1, it has completed 30 degree. How many degree it has completed? 30 degree it has completed, okay. From 1 to 2 again 30 degree, 2 to 3 30 degree, means each hour is of 30 degree, okay. So let's check it out. From 3 to 6, how many hours it has completed? 3 to 4 1 hour, 4 to 5 2 hours, and 5 to 6 3 hours, okay. Means 3 hours. 3 hours means 3 multiplied by how many degree? Each hour is of 30 degree, so 3 multiplied by 30, so we can say we have completed 90 degree. 90 degree means one right angle, so we can say one right angles we have turned. It has find the number of right angles turned through by the hour hand, okay. So 3 to 6 one right angle, okay, one right angle. Now let's move to the question number B. What the question is saying? 2 to 8. Let's check it out. 2 to 8. Okay. Now how many hours it has completed? We will check it out. Okay. 1, 2, 3, 2 to 3 1 hour, 3 to 4 2 hours, 3, 4, 5 and 6 hours. Okay. It has completed 6 hours. So we will multiply 6 multiplied by 30, because each hour is of 30 degree. 6 3 ja 18, 180 degree, okay. Means 90 plus 90 is one right angle is of 90 degree. 90 plus 90 is equals to 180, so it means it has completed how many right angles? 2 right angles, okay. So 2 right angles, okay. So this is the easiest way to do this, okay, because one calculating the hours, okay, and multiplying it by 30 degree will give you the exact value, okay, exact degree, okay. Then you can check it out how many right angles it has completed, okay, because one right angle is of 90 degree, okay. Now we will move from 5 to 11. We will move from 5 to 11. So see, 5 to 11. So we are now, our hand is at 5 and 11. Let's check it out. 5 to 6 1 hour, 6 to 7 2 hours, 7 to 8 3, 4, 5 and 6, again 6 hours. So 6 multiplied by 30, again it will come 180 degree. 180 means 2 right angle, okay. Now question number D. We are at 10 and move towards 1. So 1 2 3. How many hours we have completed? 3. So 3 multiplied by 30, 3 3 is 9, 90 degree means one right angle, okay. Now let's move to the question number D. Sorry, we have completed D. Let's move to the question number E. Question number E, what the question is saying? We are at 12. Now our hand is at 12. Move towards 9, okay. 9 like this, okay. Now let's check it out. This is the way you will not get confused if you will do the method which I have told you. Like this, if you have seen, you will get that it has completed 1 hour. Sorry, means one right angle. But it is not correct, because we have to move like clockwise, means we have to move like this, okay. So now let's check it out how many hours it has completed. 1 hour, 2, 3, 4, 5, 6, 7, 8 and 9 hours it has completed. So we can multiply 9 multiplied by 30, 3 nines are 27, 270 degree. 270 degree, 90 plus 90 plus 90 is 270. Okay, if you will not find it out like this, you can divide 2270 by 90. 0 9 3 27, so you can check it out. 3 right angle, it has completed. It has completed. Okay, that's why I'm saying you to do it like this. Calculate the hours, then multiply it by 30 degree. You will get the exact degree. Okay, and you can divide it by 90, or directly you can check it out. 90 plus 90 plus 90, because the right angle is of 90 degree. Okay, so you will get the exact answer. Okay, now we are at 12. Let's check it out, the last one, what the question is saying. We are at 12 f 12 to 6. We are at 12 and move towards 6 like this. Okay, 1 2 3 4 5 and 6. 6 hours. 6 multiplied by 30, 180. 180. Okay, you can divide it by 90, you will get 2, or 90 plus 90, okay, is 180. So you can say 2 right angle. Okay, this is the easiest way to find it out. Please don't calculate in a manner that 90 degree plus 90 degree plus 90 degree. Don't find it out like this. Okay, means 12 to 3, then 3 to 6, 90, then 90. Please don't do it like this. Okay, otherwise you will get confused when the values are like 12 and 7. Okay, or 3, or you can say 4 to 10. 4 to 10. Okay, so you will get confused that how many degree it has moved. Okay, so please don't do it like this. Okay, 5.2. let's check it out what the question number 6 is saying. How many right angle do you make if you start facing? The questions are given and we have to find it out how many right angles we are moving. Okay, I have already told you that if we move from north to east, okay, we are moving one right angle, or you can say 90 degree angle. Okay, 90 degree angle means one right angle. If we move from east to south, again 90 degree. South to west, again 90 degree. West to north, again 90 degree. Okay, means north to east we will move one right angle. Okay, so let's check it out. The question number A, what the question is saying. South and turn clockwise to west. Okay, means we are facing south, means we are standing over here. Okay, and we turned clockwise. Okay, clockwise like this. Okay, and we moved clockwise into west. Okay, to west means we are standing over here, we moved clockwise and went over here. Okay, now I am standing over here, so how many right angle we have passed? We have passed 190 degree, means one right angle we have passed. So question number A, how many right angle? One right angle. One right angle we have crossed. Okay, now question number B, what the question number B is saying. We are facing north, means now we are standing over here. Turn anti-clockwise, means anti-clockwise we have to move like this. Okay, in this direction. Okay, so now anti-clockwise to east means we are moving like this. We come to west, then again we moved towards south. Now we are standing over here towards east. So how many 90 degree we have crossed? 190 degree, 2 and 3. 390 degree we have crossed. It means we have how many right angle we have crossed? 3 right angles. Okay, 3 right angle we have made. So question number B, 3 right angles. Okay, I hope you guys are understood. I hope you guys are understanding what I am saying. Means we have already made a 90 degree angles. Okay, to show this that 90 degree angles means one right angle. Okay, so like this you can also make it. Now we are standing towards west, means now I am standing over here in west and turns to west. Okay, means we are turning like this. We can move like this, clockwise or we can move anti-clockwise as well. It doesn't matter because we are starting from west and moving and taking a complete round, okay, of 360 degree and came at that particular position only. Okay, so it doesn't matter whether we are moving anti-clockwise or clockwise, okay, because we will take a one complete round, means all the 490 degree we will cross. So all the 490 degree we will cross means we will form four right angles. Four right angle. Okay, now D. Again, it is written that right now we are facing south, means we are standing over here, and turns to north. In this also it is not given whether we are moving anti-clockwise or clockwise. Okay, it doesn't matter in this also, because if we move clockwise like this and came over here to north, so we will cross 90 plus 90, okay, means 180, means 290 degree we have crossed, mean two right angle we have crossed. Okay, if we move anti-clockwise like this, then also we will cross only two right angle, this one from south to east and east to north. Okay, means again we have crossed or we have made two right angles. So it doesn't matter whether we are moving anti-clockwise or clockwise, that's why it is not written over here. Okay, I hope you guys understood. Okay, is 5.2 we are doing. Okay, question number 7. Let's check it out what the question is saying. All the previous questions we have already completed. You guys can go and check it out the playlist. Okay, where will be the R hand of a clock stop? Okay, means we have to find it out if we move from somewhere, okay, where that R hand will stop. If it is start, question number A is saying from 6, means the clock is starting from 6 from here and turns one right angle, okay, and I've already told you the concept of finding out right angles. One right angle means 90 degree, and in the clockwise I have already told you that 1 hour is of 30 degree. 1 hour is of 30 degree. Means if we move from 6 to 7, we will complete 30 degree angle. Okay, so 7 to 8 again 30 degree, and 8 to 9 again 30 degree. One right angle is equals to 90 degree, means 30 plus 30 plus 30. Okay, means if I am starting from 6, okay, so the clock will stop at 9. It will stop at 9. Okay, so if I will move from 6, okay, and complete one right angle, okay, the clock will stop at 9. Okay, so it will stop at 9. Now from 8, if I am standing at 8 and turns two right angles, okay, means two right angle means 180 degree or 290 degree angles, so 8 to 9 30 degree, 9 to 10 again 30 degree, 10 to 11 again 30 degree, means we have completed one right angle. Now 11 to 12 30 degree, 12 to 1 again 30 degree, and 1 to 2 again 30 degree, means now we have completed two right angles. Okay, so now where we are standing, I am standing at 2. Okay, or where the R hand is or will stop, it will stop at 2. Okay, now if from 10, now R hand will move from 10 and turns through three right angles. Now we have to complete three right angles. Okay, now 10 to 11 30 degree, 11 to 12 30 degree, and 12 to 130 degree, means we have completed from here to here, we have completed 90 degree. Okay, from 1, 10 to 11, 11 to 12, 12 to 1, now we are standing at 1. 1 to 2, 2 to 3, and 3 to 4, we have completed again another 90 degree. Now from 4 to 5, 5 to 6, and 6 to 7, okay, we have completed again 90 degree. Now means the R hand will stop at 7. Okay, because 90 plus 90 plus 90 means three right angles we have completed. Okay, so the R hand will stop at 7. Okay, now we will do the last one. What the last question is saying, from 7 and turns through two straight angle. One straight angle is equals to 180 degree. Okay, two straight angle we have moved, 180 plus 180 we can say, it will become 360 degree. 360 degree means one complete rotation. Okay, and if we are moving one complete rotation, we will start at 7 and end at 7 only. So we will reach 7, or you can say our hand will stop at 7. I hope you guys can understood what I am saying. Okay, so this is the easiest way to do this question. I hope you guys understood. Today we are going to start exercise number 5.3, question number 1. Let's check it out what the question is saying. Match the following. First part is straight angle. Straight angles is of, you know that straight angle is of 180 degree. Okay, 180 degree. If we talk about in this in revolution, then how we can make? So this is a circle. Okay, straight angle is this and is this. Complete angle is of 4 revolution, 1 2 3 and 4. Okay, if it is written that straight angle means we moved like this. Okay, one rotation and the second straight line. Okay, and this is the complete revolution. Okay, so 1 2 3 4, 2 upon 4. Okay, so sorry, 2 upon 4. So 2 under 2, 2 to the 4 means 1 upon 2. We can say half of the revolution. So this is the answer. Right angle means one revolution. Okay, means right angle, we will start from here and move like this. This is one right angle. Okay, and this is only one revolution. So the right angle is 1/4 of the revolution. 1 upon 4. 1 upon 4, 1/4 of the revolution. Acute angle. What is acute angle? Acute means less than 90 degree. Okay, the angle should be like this, less than 90 degree. Okay, less than 1/4 of the revolution. 90 degree means 1/4. Okay, so it should be less than 1/4 of the revolution. So this one is 3. Obtuse angle means more than 90 degree but less than 180 degree, means more than one revolution but less than half of the revolution. So between 1/4, 1 upon 4 and 1 upon 2 of the revolution. Okay, so this one is the fourth one. Reflex angle means more than 180 degree. More than 180 degree means more than straight angle but less than complete angle. So more than half of the revolution. Half of the revolution means 180 degree. Okay, so this one is fifth. Okay, so we have completed this. Match the following. Next question we will do in the next part. Have a wonderful day ahead, guys. I hope you guys have understood how I have done it. Exercise 5.3, we are doing question number 2. Let's see what the question is saying. Okay, let's see what the question number 2 is saying. Classify each one of the following angle as right angle, straight angle, acute angle, obtuse or reflex angles. Means we have to, just by looking the figure, okay, we have to check it out whether which type of angle it is. Okay, and you know right angle is of 90 degree. If I will talk about straight angle is of 180 degree. Or acute angle is less than 90 degree. Acute angle is always less than 90 degree. Obtuse angle is greater than 90 degree but less than 180 degree. Okay, this is obtuse angle. Reflex angle is greater than 180 degree. Okay, and less than 360 degree. Okay, I hope you guys know it. Okay, all these types of angles. So just by looking at it, you can identify that whether we can take this one as base or this one. Okay, so just by looking at it, if I will take this as base, you can check it out. 90 degree angle will be like this. Okay, so it is less than 90 degrees, so we can say this one is what? This one is acute angle. Okay, and I will check it out by using the protractor. We will put it like this over here. Okay, and we will place this point over here like this, and will the base, that 180 degree line over here in the base like this. I will place it, and now let's check it out. Yes, you can check it out. 90 degree line is over here. Okay, and this one is around 40 degree. It is around 40 degree. Okay, so you can easily say that it is an acute angle. Okay, now let's move to the second one. Okay, Just by looking at it, you can easily say that this, if I will draw a line straight like this, so this one is a right angle triangle, or you can say right angle, and it is greater than right angle, but it is smaller than 180 degree line, because 180 degree line is like this. It is smaller than 180 degree but greater than 90 degree. Okay, so we can say it is an obtuse angle. Okay, so I will just place it over here like this, and you can easily check it out that 90 degree line is like this, and it is around 130 degree. It is around 130 degree, so you can say it is greater than 90 degree but less than 180 degree. Okay, so you can check it out in the question number 3. It is a straight line. Okay, the straight line is of 90 degree, so it is a right angle triangle, or you can say it is a right angle, and I will put like this. Just a second, guys. We will put it like this, and you can easily check it out that it is a straight angle. It is of 90 degree. You can check it out that it is 90 degree angle. Okay, so this is known as right, or you can say right angle. Okay, now let's move to this one. We have to find it out, this one. Okay, so you can see that if I will take base, okay, this one or this one, okay, whichever you want, you can take as base. If I will take base over here, if I will draw a line like this, so you know this is 180 degree line, and this one, okay, 180 means this angle is greater than 180, greater than 180, okay, but smaller than 360, because if I will draw a line like this, okay, then it is 360 degree line, but it is smaller than 360 degree line, so it is a reflex angle. It is a reflex angle. Okay, so by using it, just a second, you can check it out. It is, if I will place over here, so you can easily check it out that it is a more than 180 degree line. See, if I will place like this, this one is 180 degree line, and it is more than 180 degree line. Okay, so we can say it is a reflex angle. Okay, now we have to find out this one. This one is a straight line. You can easily say that it is a straight angle. It is a straight angle. Okay, if I will put like this over here, you can easily check it out that it is a straight angle line. See, it is exactly at 180 degree, so it is known as straight angle. Straight angle. Okay, so just by looking at it, you can check it out that if we are talking, we have to find out this one. Okay, so it's a straight line. Okay, so it is a straight angle. Now let's move to the last one. Just by looking at it, okay, we have to find it out, this one and this one. We can take base over here and base over here. You can easily check it out. It is, if I will draw a 90 degree line, it will be like this and like this, so it is less than 90 degree. Both are acute angles. This one is also acute angle, and this one is also acute angle. Okay, let's check it out. We'll place it like this over here. Just a second. Now you can check it out exactly at 50 degree. Exactly at 50 degree. It is a 50 degree angle. So it is a 50 degree angle. So you can easily say that it is a acute angle. Okay, I hope you guys understood how we have to find it out. Okay, just by looking the figure. Okay, I have used just to check it out and give you the information. Okay, that just by looking also you can find it out. Okay, and by using the protector you can easily find it out whether which type of angle it is. Okay,
Exercise 5.4, we are doing question number 1. All the previous exercise we have already completed. You guys can go and check it out the playlist, and please do like and subscribe my channel if you find out useful. What the question is saying, what is the measure of a right angle? What is the measure of right angle? Question number 1, and question number 2 is saying a straight angle. Okay, so I have already told you that right angle is of 90 degree. So if we draw a right angle, we will draw it like this. Okay, and this is of 90 degree. So right angle is of 90 degree. Okay, straight angle means two right angles, one right angle, and if you will do like this, two right angles. Okay, two right angles make one straight angle. So 90 plus 90 is equals to 180 degree. So this 90 and this 90, so two 90 degree angles make 180 degree angles, means 90 plus 90 is equals to 180 degree. So straight angle is of 180 degree, and this is the answer. I hope you guys understood. 5.4, we are doing all the previous exercise we have already completed. You guys can go and check out the playlist. Now for the question number 2 is saying, let's check it out. Say true or false. We have to find it out true and false in this, whether the statements are true or false. First statement, what the first statement is saying, the measure of an acute angle is less than 90 degree. Okay, so I've already told you that acute angle means acute angle is always smaller than 90 degree. Okay, so this statement is true. Now the measure of obtuse angle is less than 90 degree. No. Question number 2 is saying obtuse angle is also less than 90 degree. No, because less than 90 degree angles are always known as acute angle. Okay, and if you talk about obtuse angle, it is always greater than 90 degree but less than 180 degree. Okay, means obtuse angle is always greater than 90 degree but always less than 180 degree. Okay, please do remember. So this is false. Okay, now question number, see what is saying, the measure of reflex angle is greater than 180 degree. Yes, reflex angle is always greater than 180 degree but it is always less than 360 degree. Okay, so this statement is true. The measure of one complete revolution means we have started from here and move like this and end up over here only. Okay, so it is one circle and circle is always of 360 degree is equals to 360 degree. True. Okay, if measure of angle A, measure of angle A is given, measure of angle A is 53 degree and the measure of angle B is 35 degree. Okay, then angle A, measure of angle A is greater than measure of angle B. Yes, it is greater because angle A is 53 degree and angle B is of 35 degree. So this is, the statement is true. Okay, I hope you guys understood how we have done it. Okay, guys, 5.4 we are doing question number 3. All the previous questions and the exercises we have already completed. You guys can go and check it out the playlist. Let's check it out what the question is saying. Write down the measures of, we have to write down the measures of some acute angles. Question number B, some obtuse angle. Give at least 2 examples for each. Okay, 2 examples. They want 2 examples but I will tell you multiple. Okay, that how you can find it out. Acute angle, I have already explained you in the introduction part that acute angle is always less than 90 degree. Okay, means all the angles which is between 0 and 90 all are of acute angles. Okay, so acute angle is always greater than 0 degree and less than 90 degree. All the angles between this are known as acute angles. Okay, so if they are asking for 4 angles, 5 angles, 2 angles, whatever, you can write it down like this. Means angle of 2 degree, okay, 45 degree angle, okay, 65 degree angle, 75.5 degree angle. All these are acute angles. Okay, it should be less than 90 degree. Okay, now we have to tell some obtuse angle. I've already told you, obtuse angle is always greater than 90 degree. It is always greater than 90 degree and always less than 180 degree. Okay, means you can write it down n numbers of angles between 90 and 180 degree. Means 91 degree angle is acute, 92 degree, 145 degree, 145.5 degree, 179 degree. All these are known as obtuse angle. Okay, obtuse angles, just remember, obtuse angle is greater than 90 degree but less than 180 degree. Okay, so we have completed this question. Doing all the previous questions we have already completed. Let's check it out what the question is saying. Measure the angles given below using the protractor and write down the measures. Means we have to measure this by using the protractor. Okay, in your compass box. Okay, you can check it out. Okay, this is known as protractor. By using this we will measure, okay, and write it down the the angles, okay, measure of the angles. So what we have to do means this particular point, this one, we have to place it over here, okay, in this particular meeting points of two line segments. Okay, so this one, and you can take this one as base as well as this one. Okay, you can take any one as base. Okay, so you have to put this 180 line over the baseline. Okay, so we will put it like this, we will rotate it like this. Now we will put this point over here above it. Okay, and then we can rotate it and put it exactly like this. Okay, so you can check it out that this one is 40. Okay, this one is 40 plus this one 40, and this one is 41, 41, 42, 43, 44, and 45. Okay, this big line is, okay, half, so it is of 45 degree. It is of 45 degree. You can check it out. 40, this one is 40. We will check it out from here. 0, 10, 20, 30, 40. Okay, and this one is 45. Okay, 45. So we can write it down. The measure of this particular angle is 45 degree, and this one is the answer. Okay, now let's move to the next part, B. Now we can take this one as base. Now we will check it out like this. We will put the angle protector like this. Okay, okay, like this. So we can check it out like this by putting like this. Okay, we can check it out that this one is exactly at 60 degree. Okay, sorry, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 90, 100, 101, 120 degree. Okay, 120 degree. You can check it out. Okay, like this. This one is 90. Okay, 100, 101, 120. Okay, so this one is 120 degree. 120 degree. Now this one, we will place it like this, and you can check it out. It is a straight, exactly 90 degree angle. Okay, because it is straight. Okay, it is perpendicular. It is exactly perpendicular, and both the lines are straight. This one as well as this. Okay, so it is exactly at 90 degree. Okay, so now let's move to the last one. We can take we have to measure all the three angles, this one, and this one. Okay, so let's start from this one. Let's take this one as base, this one as base. Okay, so we will put my protector exactly like this. First of all, I will place it over here. Okay, like this. Okay, and you can check it out. 0, 10, 20, 30, 40, 50, and 60. Exactly, this one is of 60 degree. This one is of 60 degree. So this angle is of 60 degree. Okay, now let's check it out. This one first of all. Okay, so this one we can put it like this. Okay, and just like this. Okay, and by this you can check it out. It is slightly moving like this. I'll place it. Yes, now you can check it out. Exactly 90 degree angle is there. Exactly 90 degree angle is there. Okay, so you have to place it like this. Okay, to find out the exact angle, you have to place this particular point exactly at the meeting point. Okay, exactly at the meeting point. So please be very careful. Okay, this line should be overlap the baseline 180 degree line. Okay, so you will get the exact measure. Okay, so this one is of 90 degree, and now let's find out this one. We will take this one as base. Okay, so I'll move like this and like this. Okay, so you can check it out. Okay, as this one is, we will take this one as base. Okay, so we will calculate from here 10, 20, 30, 40, and it is coming to around 135 degree. Okay, so this one is 135 degree. Okay, because we have kept this one as base. Okay, so you can check it out exactly like this. Okay, by using this protector. Okay, and you will get the exact value. Okay, exact value of the angles. Okay, I hope you guys understood that how we have to use this protector. Okay, point 4 we are doing question number 5. All the previous questions we have already completed. You guys can go and check it out the playlist. Now let's check it out what the question is saying. Which angle has the largest measure? Means we have to find it out which one is the having the larger measure, or you can say larger angle. first estimate, first just by looking it, by just looking the figures, we have to find it out which one is bigger or which one is smaller. Okay, then we have to measure. Okay, then measure. Okay, measure the angle A and measure the angle B. Okay, just by looking, how you can check it out which one, which angle is greater, okay, and which angle is smaller, just by looking, okay, the distance, just by looking the distance of this point. Okay, the bigger, the bigger the points, okay, the bigger the distance of the points, the bigger the angle. Okay, means if both the angles, or you can say both the lines are like this, if both the lines are closer to each other, okay, like this, like this, if they are closer, okay, it means the angles, this angle is smaller. If it is wider, you can say the angles are bigger. Okay, just by looking it, we can say B is bigger than angle, measure of angle B is bigger than angle A. Now let's check it out, okay, by using the protector. Okay, by using the protector we will check it out. Okay, I hope you guys know how you have to use the protector. In the previous questions we have I've already explained how you have to use the protector. So just by putting this point, okay, this 90 degree, okay, and 180 degree, this perpendicular point, this one we have to put it in this particular point where both the rays are meeting. We have to put it like this. And now let's check it out. Okay, the angles, just a second. It is very difficult to put it over here in the system, so just a second, we will put it like this. Now let's this, and exactly like this. So you can check it out. This one is around 50 degrees, 0, 10, 20, 30, 40 and 50. Okay, so this one is 50 degree angle, this one is 50 degree angle. And now let's check it out. Angle A is, measure of angle is 50 degree. And now let's check it out the measure of B. We will do it like this. Okay, okay, so if we will place it like this, so it will come around 70 degree. It is around 70 degree angle. You can place it in your, by using the protector you can place it, okay, in your book or in the copy. You will exactly get around 70 degree, 70 degree angle is there. Okay, so just by seeing it, we have told that angle B is greater than angle A, and but just by measuring also we can check it out that a measure of angle B is 70 degree and the measure of A is 50 degree. Okay, so it is clear that the measure of angle B is greater than measure of angle A. Okay, I hope you guys understood, and please be careful while using the protector. Okay, you have to place 180 degree line exactly at base. Okay, so if you like the video, please do like and subscribe. Next, going to do question number 6. Now let's check it out what the question is saying. From these two angles, which has the larger measure? Okay, estimate and then confirm by measuring them. Okay, first of all, like the previous questions, we have to just look it out first of all, and we have to find it out which one is greater and which one is bigger, smaller, and then we have to find it out by measuring them. Okay, just by, I've already told you that just by looking the distance between the 2 points, okay, 2 points over here and over here, okay, which one is greater? Okay, the greater one is always having the larger angle. Okay, so we can say this one, okay, is having the larger angle. Okay, let's check it out, okay, by the protector. Okay, we can put it over here. We can take this one as base as well as this one as base. Okay, so I'll take this one as base, so I'll place it over here, 180 degree line, like this. We have to place it over here, just a second. Okay, like this. So you can check it out. It is exactly at 45 degree. Okay, means this, the measure of this angle is 45 degree. We are taking this one is angle A. Angle A is equals to 45 degree. Now let's check it out the angle B. We were taking angle A. Okay, and angle B, let's check it out. Just a second. It is exactly coming at 55 degree. Angle B is equals to 55 degree. Okay, you can check it out. Maybe there is a minor difference, okay, of 1 or 2, or it may be of 60 degree or 55, because in the system it is very difficult to put the protector. Okay, once you will draw it in the paper, pen and paper, by using the protector it will be very easy to put it over here. Okay, like this, if you will put, it will come around 40, 55 or maybe at 60 degree. Okay, so just by looking at, I have told you that this one is greater, means the measure of angle B is bigger than angle A, and we have confirmed it by measuring it at B is of 55 degree and angle A is of 45 degree. So we know that angle B is greater than angle A. Okay. Size 5.4 we are doing. Previous questions we have already completed. You guys can go and check it out the playlist. Now let's check it out what the question number 7 is saying. Fill in the blanks with acute, obtuse, right, or straight angles. Means we have to read it out and we have to fill the blanks whether the statement is of acute, obtuse, right, or straight angle. Okay. The first question is an angle whose measure is less than a right angle. Okay. Less than a right angle. Okay. Right angle means right angle is equals to 90 degree. We have already done that. So right angle is equals to 90 degree, and it is saying less than 90 degree means, let's say it can be 75, it can be 65, it can be 1 degree, it can be 2 degree, it can be 35 degree, it can be anything. Okay, but it is less than 90 degree, and we have already know that less than 90 degree angle is always an acute angle. Acute angle. Okay. B, the angle whose measure is greater than the right angle. Okay, means now the measure is greater than 90 degree. Greater than 90 degree means that it can be one, sorry, 175 degree, 95 degree, 120 degree, can be anything, but it is greater than a right angle triangle. So if we know that greater than 990 degree triangle is known as obtuse angle. Okay, an angle whose measure is the sum of the measure of two right angles, means two right angle. Okay, there is an angle whose measure is sum of two right angles. Right angle means 90 degree, 90 plus 90 degree plus 90 degree is equals to 180 degree, and 180 degree is a straight line, and straight line it means it is a straight angle. Straight angle. When the sum of the measure of two angle is that of right angle, then each of them is, means when the sum of the measure of two angles is that of right angles. Okay, means there are two angles. Okay, and the sum is 9, means right angle means 90 degree. Okay, it can be 45 plus 45 degree. Okay, it can be 30 degree plus 60 degree, it can be 35 plus 55. Okay, but when the sum of two measure is that of right angle, then each one of them is 35 and 55, 30 and 60, 45 and 45. Okay, means each one of them is less than 90 degree, so we can say both the angles, each one of them is acute angle. Acute angle, because we already know that acute angle is less than 90 degree. When the sum of two measure of two angle is that of a straight angle, and if one of them is acute, then the other should be. It is saying, the question is saying that the sum of two angle is straight angle means 180 degree. Okay, and it is saying that one angle is acute angle. Acute angle means less than 90 degree. Okay, if one angle is less than 90 degree, then other angle is always greater than 90 degree. For an example, if we take 60 degree angle, okay, so 60 minus 180 will become 120, means 120 is the another angle. 60 plus 120, and 120 is greater than 90 degree, so we can say the other one is an obtuse angle. Okay, obtuse angle. Okay, I hope you guys understood that how we have completed it. Okay, and the question is very easy, but just you have to read out the question and carefully understand what exactly the question is saying. Okay, size 5.4 we are doing question number 8. Okay, let's check it out what the question is saying. Find the measure of the angles shows in each figure, means we have to find out the measure. First estimate with your eyes. Okay, means just by looking it we have to just find it out. Okay, then find the actual measures with the protector. Then by using this particular protector, okay, we have to find out the actual measure. Okay, this protector you will get in your geometry box. Okay, I hope you guys know how to use this particular protector. Okay, so just by looking it you can just check it out. That first diagram, in the first diagram, okay, this is, if you will take a straight line like this, okay, so that line should be of 180, sorry, 90 degree. Okay, so if we draw the straight line over here like this, okay, it is of 90 degree. Okay, and this one is 90 degree line. Okay, and less than 90 degree, all angles are acute, means less than 90 degree, means in this in the first one it is less than 90 degree. Okay, and if I will draw over here this 90 degree line, okay, so you will check it out that 90 degree line means this particular angle is greater than 90 degree. It means it is an obtuse angle.
Over here also, if I will draw a 90-degree line like this, it is also less than 90 degree. It is also an acute angle. And if we will draw a line over here also, so you will check it out that this one is also a, greater than 90-degree line. Okay, so this one is also acute, obtuse angle. Okay, so just by looking it, we can say, okay, that these are obtuse or acute. Okay, it is less than 90-degree, or you can say greater than 90-degree. Okay, but to find out the actual measures, we have to use this particular protector. Okay, so we have, first of all, I will just, okay, now we have to put this particular line, this particular point, okay, at this point, okay, from where two lines two lines are meeting. Okay, so I will put over here like this. Okay, so you will see that this one is 0, 10, 20, 30, 40. Okay, this one is 40-degree angle. Okay, so I have already told you that this is an acute angle. Okay, because it is less than 90-degree, so it is 40-degree angle. Okay, so by the protector we got the exact value. Okay, now let's move to the next one. We will put it like this over here. Just a second. Yes, it is around 130-degree. Okay, means 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 20, and 30, 130-degree. Okay, okay, because this side, okay, the baseline is over here. Okay, that's why we will start from here. Okay, anti-clockwise. If the baseline is over here, then we have to start like this. Okay, then we have to take this upper values 0, 10, 20, 30, 40, 45, 56, like that. Okay, but the baseline is over here, so we have to calculate from here. Okay, so it is, I've already told you just by looking at that it is an obtuse angle triangle because it is greater than 90-degree. Okay, and we got the exact value now, that is 130-degree. Okay, and which is greater than 90-degree. Okay, so we have to just find it out over here. We will put it over here like this. Okay, so just by looking this, I will keep it over here. Just a second, guys. Yes, over here, so you can check it out 0, 10, 20, 30, 40, 50, 60. Okay, and between 60 and 70. Okay, so this one is 65-degree angle, 65-degree angle. Okay, because you can check it out, small lines are also there. Okay, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and it is coming to this one, this bigger one in the middle between 60 and 70. So we can say that this angle is of 65-degree. Okay, and which I've already told you that this one is an acute angle triangle, acute angle. Okay, because it is less than 90-degree, and we got the exact value, that is 65-degree angle. Okay, now let's move to the last one over here. We will put it over here like this. Yes, just a second, guys. Yes, around 140-degree angle is this, 10, 20, 30, 40. Okay, and you can check it out, the line is, arrow is coming over here around 140-degree. Okay, once you will keep it in the, by using the protector and pen and paper, you will easily able to place it over here in the system. It is very difficult to place this protector. Okay, so that's why it is around 140-degree. Okay, so you can say that it is an obtuse angle triangle. Just by looking it, I have already told you that it is greater than 90-degree. Okay, and exact value we got it by using the protector. I hope how you guys have to do this particular question you understood. Please do like and subscribe my channel. 5.4, we are doing question number 9. Let's check it out what the question is saying. Find the angle measures between the hands of the clock in each figure. Okay, means the hands are given, two hands are given, and we have to find it out the measure of angles between them. Okay, between the hands. Okay, so just to do this particular question, okay, I have told you the exact formula how you have to find out in the clock easily the angles. Okay, if you haven't seen my introduction part, you guys can go and check it out, my introduction video. Over there I have explained you how to find out the angles in the clock very easily. Okay, I'm explaining you once again in short over here that 1 hour is equals to 30 degree.
okay, means 1 hour is equals to 30-degree angle. Okay, if there is 1 hour, okay, it means it is forming a 30-degree angle. Okay, just by calculating in hours and multiplying it by 30, we can easily find it out the angles. Okay, now 9 to 10 1 hour, 10 to 11 2 hours, and 11 to 12 3 hours. Okay, means 3 hours. Okay, so 3 hours multiplied by 30, 3 hours multiplied by 30 is equals to 3 3s are 9, 90-degree angle, means this one is making 90-degree angle. Okay, just by doing the multiplication by the hours you can easily find it out. Okay, and now 12 to 1 hour. Okay, so 1 hour multiplied by 30, 1 3 is a 3. Okay, and 30 means 30-degree angle. Okay, means in the B part, okay, the angles is of 30 degree. Now 12 to 1 1, 1 to 2 2, 3 4 5 and 6. Okay, now 6 hours, so 6 multiplied by 30. Okay, means 1 hour is equals to 30-degree angle, so 6 hours is equals to multiplied by 30, 6 to 18. Okay, means 180-degree angle, 180-degree angle. Okay, so in the third, 180-degree angle is there. Okay, I hope you guys understood. Okay, just by doing by this particular formula you can easily find out, okay, the angles in the clock, okay. Point 4, we are doing question number 10. All the previous questions we have already completed. You guys can go and check it out the playlist. Now let's check it out what the question is saying. In the following figure, the angle measure is 30-degree, means in this particular angle figure the angle is 30-degree. This angle is 30-degree angle. Look at the same figure through the magnifying glass, means we have to use the magnifying glass better. Okay, so to look this particular figure, the question is asking, does the angle become larger? Okay, the angle become larger, does the size of the angle change? Okay, over here it is asking, does the size of the angle change? Okay, does the angle become larger? Yes, the angle become larger. Okay, the angle will look like this. If you will see from the magnifying glass this particular angle, or you can say the whole figure will get, okay, enlarged. Okay, but it is asking, does the size of the angle change? So if whether we will look like normally, okay, or by the magnifying glass, the angle will not get changed. Okay, the angle, okay, this particular angle will always remain 30-degree only. Okay, so the angle will not change. Okay, the figure will get enlarged. Okay, but the angle, the distance between this distance will remain 30-degree only. Okay, so we can say no, the size of the angle does not change. Okay, so we can mention that no, the size of the angle does not change. Okay, so you have to write in a no, the size of the angle does not change. Okay, so there will be no change in the angle. Okay, so we have done this particular question. Okay, now let's move to the question number 11. We will 5.4, we are doing question number 10. All the previous questions we have already completed. You guys can go and check it out the playlist. Now let's check it out what the question is saying. In the following figure, the angle measure is 30-degree, means in this particular angle figure the angle is 30-degree. This angle is 30-degree angle. Look at the same figure through the magnifying glass, means we have to use the magnifying glass better. Okay, so to look this particular figure, the question is asking, does the angle become larger? Okay, the angle become larger, does the size of the angle change? Okay, over here it is asking, does the size of the angle change? Okay, does the angle become larger? Yes, the angle become larger. Okay, the angle will look like this. If you will see from the magnifying glass this particular angle, or you can say the whole figure will get, okay, enlarged. Okay, but it is asking, does the size of the angle change? So if whether we will look like normally, okay, or by the magnifying glass, the angle will not get changed. Okay, the angle, okay, this particular angle will always remain 30-degree only. Okay, so the angle will not change. Okay, the figure will get enlarged. Okay, but the angle, the distance between this distance will remain 30-degree only. Okay, so we can say no, the size of the angle does not change. Okay, so we can mention that no, the size of the angle does not change. Okay, so you have to write in a no, the size of the angle does not change. Okay, so there will be no change in the angle. Okay, so we have done this particular question. Okay, now let's move to the question number 11. Exercise 5.4, we are doing question number 11. Let's check it out what the question is saying. All the previous questions we have already completed. You guys can go and check it out the playlist. Measure and classify each angle means in this particular figures, okay, some angles are given over here. It is mentioned over here. We have to write down the measures, okay, and which type of angle it is. Okay, whether it is an acute angle, it is a right angle triangle, it is an obtuse angle triangle, okay, or whether it is a reflex angle triangle. So we have to find it out, okay, and we have to mention over here, okay. So by using the protector, first of all we have to find it out these particular angles, okay, measure of these particular angle, okay. So in the compass box you will get this type of protector. You have to place it, means over here you can check it out, this center line, this particular point you have to place, okay. Here the two rays are intersecting, okay, where the two rays are intersecting means two rays are like this is the intersection point, okay. So we will place over here to find out the measure of these particular angles, okay. So we have to place this particular point, okay, in the angles where they are intersecting, or you can say where they are intersecting, okay. Means we have to place this particular dot, okay, this particular point, okay, where the angles are getting intersected, okay, like this. Over here the angle is like this, means this is the intersection point, okay. So we will place this particular point over here like this, okay. So let's check it out. Now angle is angle AOB. Now just find out the angle first of all, beta. AONB means we are talking about this particular angle, AONB, okay. So I will place this particular point over here, okay. So let's do it. We will place this point over here like this, okay. Yes, okay. So AOB, you can check it out, okay. The lines, okay. So this line is exactly at 40 degree, okay. You can check it out. The line is exactly at 40, okay. We have to mean 0, 10, 20, 30, and 40, okay. So measure is 40-degree angle it is, okay. And you know the angle which is less than 90 degree is an acute angle triangle, okay. Whichever angle is less than 90 degree, it is known as acute angle triangle, okay. So I will write it down, acute angle over here, okay, acute angle. Now let's talk about AOC, okay. Over here we are talking about AONC, means we are talking about this particular angle, okay, this particular complete whole angle, okay. So don't get confused by this particular line, okay. You don't have to take this particular line, you have to just calculate it, okay. This particular angle you have to calculate, okay. So you have to place this point over here, okay. So we will put it over here like this. Yes, and you can check it out, 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, okay, 100, 110, 120, 120, and the line is over here around 125 degree, okay. So it is 125 degree, okay. And the angle which is greater than 90 degree but less than 180 degree is known as obtuse angle triangle. Very good, obtuse angle triangle, okay. So we will write down obtuse angle, okay. You can write it down, okay, like this. Now we will talk about BONC, okay. BONC, now we are talking about this particular angle, BONC, we are talking about this particular angles, okay. So I will place this point over here, okay, and this 0-degree line over here we will take base line, this one, okay. So I will just rotate the protector first of all like this. So I will place the point over here, okay, and then I will just rotate it. Yes, now you can check it out. Yes, yes, okay. So 10, 20, 30, 40, 50, 60, 70, 80, and 85-degree angle, it is 85-degree angle, okay. And less than 85 degree and sorry, less than 90 degree angle is known as acute angle triangle. Absolutely, so this one is acute angle triangle, sorry, or you can say acute angle, okay, acute angle. So now we are talking about DONC, means we are talking about DONC means this particular, okay. So again I will place it over here, this particular point. Yes, and you can check it out, it is exactly at, just a second. Yes, now we have over here, just look at one thing better, that we have taken base over here, okay. Means the baseline is over here. So from baseline, okay, from baseline we will calculate 0, 10, 20, 30, 40, and so on, okay. So the baseline is over here, so we will calculate 0, 10, 20, 30, 40, 50 like this, okay. So once we will place this over here, So we can calculate 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, and it is coming exactly at 95-degree angle. Okay, I hope you guys understood how we are measuring it. Okay, and you know, greater than 90-degree and less than 180-degree is obtuse angle triangle again. Okay, it is an obtuse angle. Now we are talking about DONA. Okay, now DONA means we are talking about this particular angle. Okay, so we can take base this one also and this one also. Okay, whichever we want we can take as base. Okay, so I'll take it. Okay, the base is this. Okay, so I'll just rotate it. So I will put it over here. Okay, now again you can check it out because we have taken baseline is this one, so we have will calculate 0, 10, 20 from here. Okay, so exactly it is coming at 140-degree. You can check it out. Okay, so it is 140-degree angle. Again it is an obtuse angle because it is greater than 90-degree but less than 180-degree. Okay, now we are talking about B, sorry, DO and B means DO and B. Okay, so DO and B, if you will check it out, you will straight away you can say it is a straight line, and straight line is of 180-degree. Okay, so we can directly write it down that it is 180-degree angle and it is a straight line, straight okay angle. Okay, so like this we can find it out. Okay, the measure of the angles and which type of angle it is. Okay, please be very careful while using the protractor. Okay, you have to place the point, okay, exactly at the meeting point. Okay, and the 0-degree line should be straight, so you can calculate it out easily. Okay, but exercise 5.5, all the previous exercises we have already completed. You guys can go and check it out. Okay, and if you have seen, okay, so please do like and subscribe my channel. Okay, for your support. So let's check it out what the question number 1 is saying. Which of the followings are models for perpendicular line? Perpendicular line. Okay, and what are perpendicular line? I've already explained this in the introduction part of this particular chapter. You guys can check it out. Okay, over here I'm giving you the so over here I will introduce you, okay, a little bit. Okay, so perpendicular line. Perpendicular line means when the lines are intersecting each other at 90-degree. At 90-degree. Okay, means two lines are there and they are intersecting each other at 90-degree, means it is intersecting at 90-degree. Okay, then it is known as perpendicular line. Okay, it is known as perpendicular lines. Okay, so we have to check it out whether in this particular whatsoever examples are given, whether the angles is of 90-degree or not. Okay, so number one, A is saying an adjacent edges of a tabletop. Okay, means if we make a table, okay, it is like this. Okay, so means adjacent end means the ends which are meeting, okay, each other, okay, intersecting at some point. Okay, so table will always intersect at 90-degree, always intersect at 90-degree. Okay, so it is known as perpendicular line. Okay, because they are making a 90-degree angle. Okay, so this one is correct. A lines of a railway track, if we draw a railway track, it is always like this. Okay, and railway tracks are always an example of what? It is an example of parallel lines. Very good. It is an example of parallel lines because they never intersect each other. Okay, so whenever we have to give an examples of a parallel lines, okay, then we will take this particular example. Okay, so it is not a perpendicular lines. These are known as, okay, not a perpendicular lines. Okay, so we can say no. The lines segment forming a letter L. Okay, whenever we make L, we make it like this. Okay, so you can check it out. It is forming a 90-degree angle. It is forming a 90-degree angle. So yes, it is a perpendicular line because 90-degree, the formation of 90-degree angles, okay, is always contain a parallel line. Okay, so a letter V. If we draw a letter V, we will draw it like this. Okay, and it means it is intersecting over here, but it is not a 90-degree angle. It is not a 90-degree angle. So, okay, so we can say no, it is not. Okay, so I hope you guys understood how we have done this particular question. The question is very easy, just you have to be very particular, and you have to remember what are perpendicular lines, what are parallel lines. You have to remember all these things. Okay, so please, if you haven't watched my introduction part, you guys can go and check it out. Okay, on 5 we are doing all the previous questions we have already completed. You guys can go and check it out the playlist. Question number 2, let's check it out what the question is. Say, let PQ be a perpendicular to the line segment X and Y. Means PQ is a perpendicular line, means okay, to the line segment X and Y. So first of all, we will draw a straight line, okay, like this. Okay, it is known as X and Y. Okay, PQ be a perpendicular. Okay, perpendicular means straight. Okay, it is cutting x and y, okay, at 90 degree. Perpendicular means a 90-degree line, okay, means a straight line of 90 degree which is making an angle of 90 degree over here, okay, intersecting at point A means point A. What is the measure of PAY? P, we can draw it like this, P and Q intersecting at A, okay, means this point is A. Okay, so we have to write it out the angle of PAY. PAY is this particular angle. So I have already told you that this angle is of 90 degree because a perpendicular line segment, okay, perpendicular line is dividing this line segment. Perpendicular lines always cut any line at 90 degree. Okay, so whenever we are talking about a perpendicular line, it means it is making an 90 degree. I hope you guys understood that how we have done it. Okay, there are two set square in your box, means if you will take a geometry box, okay, you will get these two types of square, okay, in your geometry box. Okay, what is the measure of the angles that are formed at their corners? Okay, means we have to find it out, means what sort of angles they are making, what sort of angles they are making, means this one, this one, this one, okay, this one, okay, like this and this. Okay, so we have to measure these. Okay, so first of all, okay, if you will take, okay, set of square from any geometry box, okay, the measure of all the angles will be same. Okay, if you will take the set of square, okay, then you have to draw like this. So one set of square will be like this, okay, and then you have to measure the angles over here, like this, over here, over here. Okay, so it is of 90 degree, one is of 60 degree, and the other one is of 30 degree. Okay, and the other, if you will okay, if you measure the other set of square, it is like this, it will be like this. It is of 90 degree, this one is of 45 degree, and this one is of 45 degree. Okay, so you have to just measure these by using the protector. First of all, okay, take the set of square, place it in your book or in your copy, draw it. Okay, then you can, by using the protector, you can measure these angles. Okay, so you will find it out that 90 degree angle, that this 90 degree angle, okay, is common in both the set of square. So you can say, do the question asking, do they have any angle measure that is in common? So you can write it down, yes. Okay, 90 degree angle is called. Okay, and this is the answer. I hope you guys understand. We are doing question number 4. Okay, this is the last question of this particular exercise 5.5. Now let's check it out what the question is saying. All the previous question of this particular exercise and the previous exercise we have already completed. You guys can go and check it out the playlist. Now, study the diagram means we have to first of all study this particular diagram. The line L is perpendicular to line M. Okay, means this particular line L, which is given to us, is perpendicular to line M. Okay, is means we have to find it out. Is CE means CE is equals to EG. Okay, so you can check it out that CE between this, okay, there is only one unit, that is 4. Okay, and if we talk about E and G, from E towards G there is also one unit, that is 6. Okay, so is this common? Means CE means from CE is equals to EG. Yes, we can say yes. Okay, just by looking at that between this there is only one unit, over here also between these two there is only one unit, so we can say yes, CE is equals to EG. Okay, now the P part of this, does PE, now we are talking about P and E. Okay, this one, P and E bisect CG, means bisect means bisector. Bisectors always divide a line into two equal part, okay, means if I will draw a line L, if I will bisect it, means PE means P and E, this particular line is bisecting this particular line, it means this part is equal to this part. Okay, bisector means divide a line into two equal part. Okay, so now let's check it out whether it is dividing it into equal half or not. So E, after E, or you can say E, 1, 2 and 3 units are there. Over here 1, 2, 3, 4 units are there. Okay, this side there are 4 unit. Okay, if I will include 0, it will be 5 unit. Over here 1, 2 and 3 units are there. So we can say that no, it is not dividing into two equal part. Okay, so we can clearly see that no. Okay, so it is not a bisector. Okay, because it is not dividing into two equal half. Okay, if it is a bisector, it means that it will always divide into two equal half. Okay, let's move. Now let's move to the part C. Identify any two line segments for which PE is a perpendicular bisector. Perpendicular bisector means it will divide into two equal parts. Okay, so we can say PE like this. We can draw over here. PE is this line. Okay, so we have to find it out the perpendicular bisector. Perpendicular bisector means it will divide that particular line into two equal parts. Okay, so we have to find out two line segment. Over here we can take D, and over here we can take F. Okay, so you can say DE is equals to EF. Okay, it means EP is a perpendicular bisector for D or F. Okay, now we can take C and E is equals to E and G. Over here also it will be dividing into two equal part, means C and E is equal and E and G is equal. Okay, it is dividing into two equal part. Okay, so these are the two line segments. We can write it down. Now it is now the question, the part D is saying, are these two, means AC is greater than FG. AC means this one AC, okay, is greater than FG. F and G, yes, you can say, because in the center there is one unit present. Okay, over here there is no unit. Okay, so you can say yes. Now CD means we are talking about CD. This part is equals to GF, G and H, sorry, G and H. So you can say there is no unit between these 3 and 4. Okay, or you can say C and D, and there is also no unit is there between G and H, or you can say 7 and 8. Okay, so you can say yes, it is equal. Now BC, we are talking about BC is smaller than EH. E from here to here, yes, it is clearly mentioned, or you can say clearly see that in between there are two units, 6 and 7. Okay, and there is no unit, so you can say, okay, so BC is greater than, sorry, BC is smaller than E and H, we can say yes. Okay, so like this we have completed this particular question as well, this particular exercise. Okay, we are going to start exercise 5.6, question number 1. Let's check it out what the question is saying. Name the types of the following triangles, means we have to check it out the measures first of all, and okay, then we have to identify that which type of triangle is it. Okay, question number A, triangle with length of side 7 centimeter, 8 centimeter and 9 centimeters. Okay, means the triangle is like 7 centimeter, 8 centimeter and 9 centimeter. It is like this, means all the angles, okay, sides means 7 centimeter, 8 centimeter and 9 centimeter, means all the sides are not equal. All the sides are not equal. So whenever all the sides of a triangles are unequal, it is known as scalene triangle. Okay, it is known as scalene, SCALENE, scalene triangle. Okay, it is known as scalene triangle. Okay, whenever all the sides of a triangle is unequal. Now question number B, ABC, where AB is, means let's say if we have drawn an angle like this, it is a triangle like this, A, B and C. Let's name it. AB is equals to 8.7, AC is equals to 7 centimeter and BC is equals to 6 centimeter. Okay, again you can check it out that all the lines are unequal. Okay, so it is also an scalene triangle, SCALENE, scalene triangle. Okay, it is an scalene triangle. Now let's move to the third part, PQ and R. PQ and R. So P, Q, and R. These are, okay, these are the lines. So such that PQ, okay, PQ, QR, and PR is equals to 5 centimeter, means all the sides are of 5 centimeter, 5 centimeter, and 5 centimeter. Okay, when all the sides of a triangle are equal, so it is known as, means all the sides are equal, so it is known as equilateral triangle. Okay, so EQUILA, equilateral triangle. Okay, it is known as equilateral triangle whenever the sides of triangles, all the sides of triangles are equal. Okay, now let's move to the D part. Okay, in D part it is written DEF. Okay, with M, measure of angle D, means like this, is equals to 90 degree, means angle D, this is angle D, this is angle D. Okay, so we can say D, E and F. Okay, D is of 90 degree. Okay, whenever there is a 90-degree angle is there, so it is known as a right angle triangle. It is known as right angle triangle. Now let's move to the question number E. Okay, over here it is written X, Y and Z is there. Y is of 90 degree, means okay, x, y, and z. Y is of 90 degree. So, and x, y, okay, means xy, this one and this one is equal means two sides are equal and one is 90-degree angle. Okay, so it is known as two. Whenever in a triangle there are two sides are equal, so it is known as isosceles triangle. And there is one right angle triangle, so it is known as isosceles right angle triangle. Isosceles right angle triangle. It is known as isosceles right angle triangle. Okay, whenever two sides of a triangle are equal, okay, and one is of 90 degree, it is known as isosceles right angle triangle. Now let's move to the last part. Okay, L, M, and N is there. Okay, now angle M is of 30 degree, means I can say L, M, okay, or we can draw like this, L, M, and N. L is of 30 degree, okay, M is of 70 degree, and N is of 80 degree. Okay, like this. Okay, means, so which type of a triangle is it? All the angles are, you can say all the angles are unequal, means there is no 90-degree angles. Okay, and you can check it out that all the angles, the measure of all the angle is less than 90 degree. The measure of all the angle is less than 90 degree. Whenever this type of situation is there, okay, it is known as acute angle triangle. Okay, because the angles which are less than 90 degree are known as acute angle. So all the angles are acute, so we can say that acute angle triangle. It is known as acute angle triangle. I hope you guys understood that how we have done this particular question. The questions are very easy, just you have to understand the concept, okay? And in the introduction part, each and everything I've explained, okay, about these angles, okay? So you guys can go and check it out. Guys, 5.6 we are doing question number 2. We are going to start today. All the previous questions and the exercises we have already completed. You guys can go and check it out the playlist. Now let's continue what the question is saying. Match the following means we have to read, okay, and we have to match with the correct option. Okay, so three sides of equal length, okay, means there is a triangle which are having, okay, all the sides are equal. So whenever there is all the sides are equal, three side triangle have three sides, all the three sides are equal, so it is known as equilateral triangle. So this one is correct, this one is one. It is known as equilateral triangle. Now two sides are of equal length, okay, means a triangle is like this. Okay, we can say two sides are equal, means this one and this one, okay, are equal. Okay, so whenever two sides are equal, so it is known as isosceles triangle. Okay, the definition of isosceles triangles is whenever two sides of a triangles are equal. Okay, so it is known as isosceles triangle number 2. Now all the sides are of different length, means like it is of 6 centimeter, it is of 7, and it is of 8 centimeter. All the sides are unequal. Okay, so it is known as scalene triangle. It is known as scalene triangle. Now three acute angles. Okay, whenever if there is a diagram like this, okay, acute angle means less than 90 degree. Okay, the measure of the angle is less than 90 degree. So whenever this type of question is there, okay, it is known as 90-degree angle. Less than 90-degree angle are known as acute angle. Okay, and if all the sides, or you can say all the angles of any triangle is less than 90 degree, it is known as acute angle triangle. Okay, as simple as that, acute angle triangle. So acute angle triangle means this one. This one is fourth one. Okay, it is known as acute angle triangle. One right angle is there, okay, means 90-degree angle is there. Okay, so it is known as, simply it is known as right angle, means one right angle means right angle triangle. This one is right angle triangle. One obtuse angle, obtuse means greater than 90 degree, greater than 90 degree. Okay, so if there is an angle, okay, greater than 90 degree, it is known as obtuse angle, means obtuse angle triangle. Okay, so this one is obtuse angle triangle. One right angle with two sides of equal length, means there is one 90-degree angle is there, okay, and two sides are equal, means this one and this one is equal. Okay, whenever I've told you that two sides of triangle is equal, this is known as isosceles triangle. But over here one side one angle is of 90 degree. Okay, so it is known as isosceles right angle triangle. Okay, it is known as isosceles right angle triangle. I hope you guys understood that how we have done this. Okay, the question is very easy. Okay, just first of all clear your concepts. Okay, if you haven't watched my introduction video, you guys can go and please check it out, the introduction videos.
Check it out, the introduction video, try to do these questions by yourself. Okay, then you can check it out whether you are right or wrong. Okay, so please be with me. Okay, let's do it. What the question is saying: name each of the following triangles in two different ways. Means to find out which type of triangles which type of triangle is this, there are two different ways. Okay, just first is just by looking the angles, that's which angle it is forming, whether it is an obtuse angle triangle, acute angle triangle, right angle triangle. Okay, what are these angles? I'll tell you. Okay, but in briefly I've explained you in the introduction part. You guys can go and check it out. Okay, so if the angle is less than 90 degree, it is known as acute angle triangle. Okay, if it is exactly at 90 degree, it is known as right angle triangle. If the angle is greater than 90 degree, okay, and less than 180 degree, okay, so it is known as obtuse angle triangle. Okay, and if it is greater than 180 degree but less than 360 degree, it is known as, very good, reflex angle triangle. Okay, just by this we can find it out which type of angle are these. Okay, and by checking out the sides, okay, means if all the three sides are equal, we can check it out. We can say that it is an equilateral triangle. If the two sides of a triangle are equal, it is known as isosceles triangle. If means either sides mean all the three sides are different, so it is known as scalene triangle. Okay, so these are the two methods by which we can find out which type of triangle is it. Okay, so we don't have to use any protector over here, just by observation we can find out. Okay, we have to mention which type of angle it is. Okay, so in this figure you can check it out, this particular angle, this one, it is greater than 90 degree, because you know the 90 degree angle is straight like this. Okay, means if there is a perpendicular line, means straight line, okay, it is known as 90 degree, okay, angle. But it is greater than 90 degree, because if I will draw a perpendicular line over here, so I can draw it like this. Okay, so you can check it out, it is greater than 90 degree, okay, and it is less than 180 degree, so it is known as obtuse angle triangle. So this one, A, is obtuse angle triangle. Okay, now it is an obtuse angle triangle. So now two different ways you can check it out. All the sides of this particular triangles are not equal, yes, are unequal. Okay, so it is known as, what it is known as, scalene triangle. Very good, scalene triangle, because all the sides are unequal. Now let's move to the B part. Over here you can check it out. Okay, means if we take a base over here like this, okay, so you can check it out. Over here it is less than 90 degree. If I take a base like this, if I will draw a line like this, a 90 degree line, so you can clearly see that this particular angle, means it is formed like this, means it is less than 90 degree. Okay, and if I take a base, I kept a protector over here, so 90 degree line will be drawn like this, and the triangle is drawn like this. Okay, so it is from here also, it is less than 90 degree. Okay, so it is also known as, it is known as acute angle triangle. It is known as acute angle triangle. Okay, because if I will take a base over here, so it is less than 90 degree, it is less than 90 degree. Okay, I hope you guys understood how we have done it. Okay, and you can check it out. But over here two sides are equal. Whenever the two sides are equal of a triangle, it is known as isosceles triangle. Okay, isosceles triangle. Okay, so it is known as isosceles triangle. I hope you guys understood. It is very easy. Okay, now let's move to the next part. Over here you can check it out that if I will draw a line like this, 90 degree line like this, so it is greater than 90 degree, so it is clearly that it is an obtuse angle triangle. Obtuse angle triangle, and you can check it out. Two sides are equal of this particular triangle. Again, it is known as isosceles triangle. Okay, now the D part over here, you can check it out that it is exactly forming a 90-degree angle. What it is forming? It is exactly forming a 90-degree angle. Okay, so it is forming a 90-degree angle. It means it is a right angle triangle. Okay, right angle triangle. Okay, and you can check it out all the sides. Just by using the sides, we can check it out that all the sides are unequal. Okay, so it is known as scalene triangle. Very good. Scalene triangle. Over here, you can check it out that 90-degree angle, because this particular line is straight perpendicular to this particular side. It is known as 90-degree angle. So again, it is known as right angle triangle. Okay, and two sides are equal. Again, two sides are equal, so it is known as, when two sides are equal, so it is known as isosceles triangle. Isosceles triangle. Now over here, you can check it out. Over here, this angle, if we draw a perpendicular line like this, means it is less than 90-degree. If I'll keep a protector over here, if I'll draw like this, so it is less than 90-degree. So means less than 90-degree means it is forming an acute angle triangle. Very good. And you can check it out, all the three sides are equal. Whenever all the three sides are equal of a triangle, it is known as equilateral triangle. Equilateral triangle. I hope you guys understood that how we have completed this particular question. The questions are very easy. Okay, you just have to learn the concept. Okay, so for that, go and check it out, the introduction part. I hope you like my videos. Please do like and subscribe my channel, and please do share with your friends. Okay, now let's check it out what the question is saying. Try to construct a triangle using the matrix. Means some matrix are given to us. We will try to make some triangles by using that particular matrix. Okay, some are shown here. Means these are some examples shown to us. Okay, can you make a triangle with? Means we can make a triangle by using three matrix. Means we are having three matrix, four matrix, five matrix, and six matrix. Okay, now there is one remark that is given to us. Okay, that is, remember, you have to use all the available matrix. Okay, means we cannot keep one or two matrix with ourselves. Okay, and we will use rest of the matrix to make a triangle. We cannot do that. Okay, means we have to make a triangle by using all the matrix given to us. Okay, if you are not able to means make a triangle by using those numbers of matrix, you have to think. Okay, and we have to think the reason. Okay, so let's do it by using the three matrix. Before using the matrix, one concept I have to explain you in the introduction part. That part has been completed. If you have watched, okay, you will just revise this over here. That to make a triangle, there is one concept that sum of two sides of a triangle should be greater than the third one. Okay, means this is the theorem that sum of two sides, any two side we can take, sum of any two sides of a triangle should be greater than the third one. Okay, means should be greater than the third side, or you can say the third one. Okay, just by using this, okay, we have to do this particular question, whether we can make a triangle by using all the matrix or not. Okay, so in question number A, three matrix are given to us. Means by using the three matrix, we can easily make a equilateral triangle. Okay, so yes, we can make a triangle, and we can make equilateral triangle by using this. Okay, means like this, one matrix, two, okay, and three. I can make three matrix, and it is known as equilateral triangle. Okay, by using the four matrix. Now if we use four matrix, okay, I have to make a triangle like this. Means one matrix, two matrix, three, okay, three matrix and four matrix. We have to make like a triangle like this. Okay, because okay, but if you add any two sides of this particular triangle, means let's say it is known as
side 1, side 2 and side 3. Okay, if I'll add side 1 plus side 2, okay, means 1 plus 1, okay, sorry, 1 plus 1 is equals to 2, and it is not greater than, the third side. Okay, so by seeing this, we can say by using the 4 matchsticks we cannot make a triangle. Okay, so no, we cannot make a triangle by using 4 matchsticks. Okay, because the theorem which is given to us, sum of two sides of a triangle should be greater than the third one, it is not applicable over here. By using the 5 matchsticks, let's check it out. 5 matchsticks is given to us. Okay, just by using the 5 matchsticks we can easily make a triangle. Means we can keep one over here, second, third, fourth and fifth. Okay, and over here this one and this one, these two sides are equal because both sides are made up of two matchsticks. Okay, so it is written as, yes, we can make an isosceles triangle. We can make, using the 5 matchsticks we can make an isosceles triangle because two sides are equal. Okay, now 6, by using the 6 matchsticks we have to find it out whether we can make or not. Okay, so it is very easy. By using 2 matchsticks each side we can easily make an equilateral triangle. Yes, we can make an equilateral triangle. Okay, I hope you guys understood that how we have done it. Okay, use the concept that sum of two sides should be greater than the third one. Okay, go and watch the introduction part first of all, because I have cleared each and everything over there in the easiest manner possible. Okay, just by watching the introduction part you can do all these questions very easily. Okay, so try to watch the introduction part first of all, try to solve these questions by yourself. Okay, then watch the video completely and check it out whether you are right or wrong. Okay, and then learn, okay, where you are wrong. Okay, so let's continue. Means we have to find out true and false in this particular case. In okay, a part is saying each angle of a rectangle is of right angle. Okay, this is true. How? I'll explain you. Right angle means a rectangle is like this. Okay, and each angle of a rectangle is of 90 degree, because all these lines are perpendicular, to each other. Okay, so now B part, what the question is saying, the opposite side of a rectangle are equal in length. Yes, it is true. How? Means you can check it out. Means like it is a rectangle, it is of 5 centimeter, it is of 5 centimeter, it is of 2 centimeter, it is of 2 centimeter. Okay, so opposite sides are equal. Okay, so it is true. Now the third part, the diagonals of a square. Means diagonals means if I'll make a square like this, a square means all the sides are equal. Okay, and if I'll draw a diagonal like this, okay, sorry, like this, so you can check it out. It is asking, are perpendicular to one another? Yes, if you'll check it out, means this is the base and this line is perpendicular because it is making a 90 degree angle over here. Okay, it is also making a 90 degree angle over here as well, over here. Okay, so yes, it is true. Okay, sorry, it is true. Okay, now let's do the next part. All the sides of a rhombus are of equal length. Yes, all the sides of a rhombus are of equal length. That is the property of a rhombus, that all the sides are equal. That is true. All the sides of a parallelogram are of equal. So over here, next question, question number E, all the sides of a parallelogram are of equal length. Okay, means we have to find out, means whether parallelogram means each parallelogram are of equal length, means all the sides. So it is false, because in the parallelogram opposite sides
are of equal length, because if it will become of equal length, then it will become a rhombus. Okay, so it is said that, okay, it is said alternate side are equal in the parallelograms, or you can say opposite sides are equal in the parallelogram. Okay, the opposite sides of a trapezium are parallel. Okay, so this one is also false, because if we make a trapezium, we will make like this. So over here you can check it out, these two sides are parallel but not these. Okay, so we can say it is false, because okay, only one pair of side, okay, in a trapezium is parallel. Okay, I hope you guys understood that how we have done this. Okay, about that introduction part. Okay, after that you can solve all these questions by yourself. Okay, so first of all, go watch the introduction part if you haven't watched. Okay, again, do try to do these questions by yourself. Okay, then check it out whether you are right or wrong. Okay, so let's find out. Give reason for the following means we have to give the reasons for the following. Okay, a square can be thought of as a special rectangle, so we can say yes, we can do that. How we can do that? A square can be thought as a special rectangle. If you take a square, if you take a rectangle, all the sides means all the angles are of 90 degree. Okay, all the angles are of 90 degree, so we can say, so in the square, okay, is a special rectangle. Yes, because all the angles are of 90 degree and opposite sides are also equal. Over there in the rectangle, opposite sides are equal. Over here also opposite sides are equal, so we can say yes, because we have to give the reason, so we can write it down the reason. Okay, that all the angles is of 90 degree. Okay, and opposite sides are equal. Now B part, if you check it out, the B part of this, a rectangle can be thought as a special parallelogram. Okay, over there we can say yes. How? I'll explain you. A rectangle, over here in a rectangle, okay, and over here in parallelogram, you can check it out, opposite sides, okay, are equal. Okay, so we can say yes. Okay, in both opposite sides are equal. Okay, so we can say yes. Now third, a square can be thought as a special rhombus. Yes, we can say that, because how? If I'll make a square, all the sides are equal. Okay, and in rhombus also all the sides are equal, so yes, it is a similarity. Yes, why? All the sides are equal. Okay, and one thing more you can know, that over here if I'll draw a diagonal, okay, in the rhombus, okay, and in the square, diagonal is perpendiculars. Okay, so we can say diagonals are perpendicular. Okay, so now D, square, rectangle, parallelogram are of all quadrilaterals. We can say yes, all these are quadrilaterals, because all the quadrilaterals are an enclosed figure made up of four sides, so square is also an enclosed figure, rectangle is also an enclosed figure, parallelogram is also an enclosed figure, and all these are made up of four sides, so we can say yes. Square is also a parallelogram. If we say a square is a parallelogram, you can say yes, because over here we can give the clarification, like in the parallelogram opposite sides are equal, over here opposite sides are equal. Okay, so I hope you guys understood all the concept, that how we have to do this. Okay, means we have to compare between two. If they are having a similarity, so we can say yes. Okay, otherwise we can say no. Okay, so, and we have to mention the give reason, means we have to give the reason to these particular questions. Okay, and 7 we are doing question number 3. Okay, all the exercises are there in the playlist. You guys can go and check it out, the playlist. First of all, I request you guys, first of all, go and watch the introduction part of this particular chapter. Over there I have explained each and everything in the easiest manner possible. Let's read out the question, what the question is saying. A figure is said to be regular if its sides are equal in length. Okay, means all the sides are equal, and angles are equal in measures, mean all the angles are also equal in measures. Can you identify the regular quadrilaterals? Now what is quadrilateral? Over there in the introduction part I have explained clearly. Okay, so I'm just giving you the small example that quadrilateral means having four sides and it is an enclosed figure. Okay, it is an enclosed figure having four sides. Okay, so all the sides should be equal and all the angles should be equal, so we can identify that regular quadrilateral is a square. Okay, because all the four sides are equal. Okay, and all the angles are equal. Okay, 5.8 we are doing today. All the previous questions we have already completed. You guys can go and check it out. Now let's check it out what the question number 1 is saying. Explain, or we can say examine whether the followings are polygons, means we have to find out whether they are polygons or not. If any one among them says not, say why they are not a polynomial, sorry, why they are not a polygon. Okay, so first of all I want to know what are polygons. Polygons are enclosed figure made up of straight line, okay, these are known as polygons. Okay, means the figure should be enclosed and it should be made up of straight lines. Okay, so if I will check it out, first one, it is made up of, the figure is made up of straight lines. Okay, but the figure is not enclosed, so we will write it down, no, it is not. Okay, second figure is yes, because it is made up of straight line and it is an enclosed figure. Okay, we can write it down, no, because it is a circle, it is not made up of straight line. Now if we will check it out, the fourth one, it is also no, because two straight line are there, but the third one is a curve line, so we can say no to this also, because by using this particular statement you can justify your answer. Okay, I hope you guys understood that how we have done this particular question. Okay, just do remember this particular statement, because to clarify your answer you have to write it down this particular line. Okay, name each polygons, means there are some figure given to us, we have to name them. Okay, make two more examples of each of them, means we have to make two more example by ourselves. Okay, so just by seeing this figure we have to tell which type of polygon it is. Okay, so question number A part is saying, so we have to count the number of line segments. So A, first of all what we have to do, we have to count the line 1 2 3 4. 4 means it is a quadrilateral, so A is a quadrilateral, QUADRILATERAL. Okay, that is quadrilateral. Now you can check it out, 1 2 3. Okay, and it is a 90-degree angle is here, so B1 is a right angle triangle. Okay, having three sides and one side is of 90-degree. Now next one, C, 1 2 3 4 5, having 5 sides, so it is known as pentagon. Okay, now the next one, 1 2 3 4 5 6 7 8, 8 sides are there, so it is known as octagon. Okay, octagon. Now we have to make two more, okay, by ourselves, so I'll make one by, okay, my side. Okay, one you have to make it by yourself. Okay, and what you have made, you name that particular polygon on the comment. Okay, so one I will make, that is E1 is hexagon. I'll make hexagon. Hexagon means having 6 sides. I'll make it 1 2 3 4 5 and 6. Okay, and this is known as hexagon. Okay, so and the next one you have to do it by yourself. Okay, you have to comment me on the comment box. I'll definitely reply, okay, that you guys are right or wrong. Okay, 5.8 we are doing question number 3. Okay, all the previous questions we have already completed. You guys can go and check it out. All the introduction part is there in the playlist. You guys can go and check it out. I've explained each and everything briefly and the easiest manner possible. Let's check it out what the question is saying. Before this, if you haven't subscribed my channel, please subscribe my channel and like the videos. Draw a rough sketch of a regular hexagon. Okay, we have to make a regular hexagon. What are hexagon? Hexagon is a polygon having 6 sides. Okay, connect any 3 of its vertices, draw a triangle and identify the type of triangle you have drawn. Okay, so what we have to do, we have to first of all draw a hexagon. So let's draw an hexagon. So this is an hexagon. Okay, now what the question is saying, connect the 3 of its vertices. Okay, means we can name it A, B, C, D, E and F. Okay, now what we have to do, we have to connect 3 of its vertices to draw a triangle. So if we can connect these two like this vertices. Okay, so identify the type of triangle you have drawn. Now if you watch, what is the property of a hexagon? All the sides of a hexagon are equal, means this side is equal to this side, means all the sides are equal. Okay, so if I will check that this side is equal to this side, and if I have drawn this particular triangle, okay, 2 sides are equal in this particular triangle. So what is the type of triangle it is? It is an isosceles triangle. Yes, isosceles triangle are triangles having 2 sides equal. Okay, so the triangle is an isosceles triangle. Okay, I hope you guys understood that how we have done this. Okay, next number 4th of this particular exercise, let's check it out what the question is saying. Before this, if you haven't subscribed my channel yet, okay, please do subscribe my channel and like my videos. Draw a rough sketch of a regular octagon. Okay, so octagon, so what type of polygon it is? Octagon is a polygon having 8 sides. Okay, so we have to make a regular octagon. So let's draw it. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so we have drawn a regular octagon. Now what the question is saying, that draw a rectangle by joining exactly 4 of its vertices. Okay, means first of all we can name all these vertices, means A, B, C, D, E, F, G and H. Okay, so draw a rectangle by joining exactly 4 of its vertices. So if you check it out, to make a rectangle we can join these vertices from H to E and A to D. So this is a rectangle. Okay, and we have to just show a rectangle by joining the vertices. So by this we have to do this particular question. I hope you guys understood that how we have done it. The questions are very easy, but just you have to check it out, read it out carefully, that what we have to make. Okay, and please remember that octagon is having 8 sides. Okay, 5.8 we are doing question number 5 of this particular exercise. All the previous exercises we have already completed. You guys can go and check it out the playlist. Question number 5, let's check it out what the question is saying. Before this, if you are new, if you are watching my video first time, please subscribe my channel. Okay, draw a diagonal is a line segment. What is exactly a diagonal is? Diagonal is a line segment that joins 2 vertices. Okay, that we exactly know in the introduction part. I have already explained this thing. Okay, that diagonal is a line segment that joins 2 vertices of the polygon, and it's not a side. Okay, and we cannot consider it as a side. Okay, so draw a rough sketch of a pentagon, means we have to draw a rough sketch of a pentagon and draw its diagonals, and we have to draw the diagonals. So first of all, what is exactly pentagon? Pentagon is a polygon which is having 5 sides. Okay, so let's draw a pentagon first of all. 1, 2, 3, 4 and 5. Okay, this is a pentagon I have drawn. Now let's first of all mark the vertices is A, B, C, D and E. All these are vertices. Okay, now what we have to do, we have to draw the diagonals. Okay, so first of all we have to draw the diagonals. So let's draw the diagonals. From B we can connect E. Okay, diagonal number 1. From B we can connect D, that is diagonal number 2. From C we can connect E, okay, diagonal number 3, and from C we can connect A, okay, that is diagonal number 5, and from A we can connect diagonal number D. Okay, so all these are diagonals. Okay, so all these are diagonals. How many diagonals are there? There are 6 diagonals. Okay, but we don't have to mention how many diagonals we can make, we just have to make the diagonals. Okay, so just by doing this particular question like this, you can show that these are diagonals. I hope you guys understood that how we have to do this particular questions. Okay, exercise 5.9, match the following. We have to match the following. Okay, so we have to first of all check it out the figure and do it. Okay, so the cone is this. Okay, so I will write over here A. Sphere, okay, means a circle, so it is known as B. Cylinder, okay, is C. Cuboid, this one is the cuboid, that is D, and pyramid is E. Okay, now the question is also asking something. Give two new example of each shapes. Okay, means of like of cone we have to give some example, we have to give some examples of sphere, we have to give some example of cylinders. Okay, so in the next question, okay, in question number 2 you will get some answers regarding these topics. Okay, means these shapes. Now the question number 2, what the question number 2 is saying, what shape is, okay, let's find it out. Your instrument box, okay, any instrument box is like a cuboid maximum. Okay, so we can write it down. The instrument box can be of cuboid, okay, can be in a shape of cylinder, okay, or can be in a shape of pyramid or a sphere. Okay, so we can write it down. Okay, means the instrument box is, we can write it down cuboid, so there is no problem in that. Okay, a brick, okay, a brick is an example of what? A cuboid. Brick is an example of a cuboid. So give 2 new examples, you will get the examples from here. Okay, we can write it down bricks as well. A matchbox is also like this. Okay, so cuboid, the matchbox is an example of cuboid. A road roller, so we will write it down. I will write it off cuboid over here as well, cuboid over here as well. Okay, and I can write it down cuboid over here as well. Okay, now I will talk about what a road roller. A road roller is like this. The shape of a road roller, if you have seen, like it is like this, and it is cylinder. Okay, okay, it is an cylinder. A sweet laddu, okay, a laddu is a sphere, it is like this, round in shape. Okay, so I'll write it down sphere in it. Okay, I hope so you guys understood. Okay, you can recognize all these shapes. Okay, and you got the answers. Okay, so over here we have finished this particular chapter. Okay, the chapter is a little bit lengthy. Okay, try to solve each and every questions of this particular chapter. Okay, have a wonderful day ahead, guys. Bye bye, take care. Please do like and subscribe my channel. Have a great day. Bye bye.